Okay, so today what we're going to do is we're going to go through kind of all the crashes that we found last night. We just had it up and running overnight, and we got, let's see here, looks like we got about 51,000 fuzz cases in last night. A lot of the fuzzers ended up falling offline just due to panics and things that I eventually need to fix up in this fuzzing harness. Nothing wrong with that. It still ran for a good like 4 or 5 hours with 64 cores. And I'm really happy with that, especially since a lot of this code is relatively new. So we're going to go through kind of all these different crashes that we had. I don't think we have this many crashes here as it seems. I think we only have maybe 10 or 12 unique crashes, and I'm going to talk a little bit about why I think that's the case. So, all right, how's everyone doing? I'm going to post one more Twitter link to say that we are now live. Okay. Wow, why is that a outdated thing? All right, what's up, Hobo Danger? Thanks for following. Yeah, take it off intermission if we're starting. Yep. I'm trying to figure out why this tweet is, for some reason this tweet, decided to post Twitter has the wrong thing cached for that Twitch page, so the link isn't valid. It says reversing MapleStory with Ghidra, which is, an ancient thing. I don't know how to update that. Whatever. Twitter people will figure it out. All right. So, look at that. Fancy. So, what we're going to do is we're going to hop in and start looking at some of these crashes. I've noticed a little bit of repetition on some of these. So, for example, all these crashes seem to end with an AC49. And they're also in help pane, but I can guarantee you that I don't think these crashes are actually in help pane. I think they are in calc. So we're going to go through quickly, and we're going to try and reproduce those bugs, and we're just going to see where they actually end up crashing. So I'm going to spin up my KD server there, my debugger. Then we're going to hop over here, and we're just going to have this go through and repro that crash. So I'm just going to give it the file name of that crash. Which is not my Twitch link. We're gonna let's grab this help pane 3AC49, rename this, grab this, and now this should connect up to here, and we're gonna be able to see this reproduce. So what I suspect is that I actually have an issue when a process maps at the same address as calc.exe, and if we look at this, I can guarantee it's gonna be calc. Yep, we're in calc update history. This is a bug that we know about. So I think pretty much all of the bugs that we see in this crash log that end with approximately the same suffix, like the AC49, anything with the same last 3 digits, because the last 3 digits are the page alignment, and those will never change. Technically, I think Windows does not move things outside of a 16K boundary, or a 64K boundary, so I think the last 4... any ones where the last 4 are the same are actually the same crashes. And the reason for that is, let me put this into a reasonable font. I did a little bit of hacking on this stuff last night. Whoa. I think H16? There we go. So I'm going to switch this into this font. I think this font is plenty readable on stream. Probably not for mobile people, but there's only so much of a sacrifice I'm going to make on usability of a development environment. So what we're going to look into is how we handle coverage. So I can talk through roughly how we do that in this tool in TKO fuzz. So TKO fuzz is a system-level deterministic fuzzer built on box. So effectively what we do is we use box. When we boot up Windows or whatever you want to fuzz, it can be Linux, Windows, anything that runs on x86, or more specifically, what runs in box. If you boot that up in box, we're able to take a snapshot of that. And if we take a look at here, we ended up making a box image. We have a VHD with Windows installed. We booted it up. We got to the desktop. Once we got to the desktop, we opened calculator, and then we kind of waited for the system to become idle. We wanted to let Windows get done with all of the like operations it was doing behind the scenes during the boot sequence, mainly because the more stuff going on the system, the more noise and ultimately the slower our fuzz cases would be. So we ended up taking a snapshot, and this is just a standard box snapshot. We didn't do anything fancy here. This saves kind of a copy of the hard drive. It saves all of the memory contents, and then it saves the state of various different devices. For example, if we looked at CPU 0, this will have all of the register and MSR states for the processor in the state of the snapshot. So what we do there in TKO fuzz is we've now kind of finished up with the box side of things, and we go into TKO fuzz and we reload that snapshot. So if I were to open up a command prompt here, technically I do this in Franzia, so we'll go into the Franzia folder, and we have the TKO fuzz tool here, which is not happy because it's already running. No surprise. I think it's this one. So TKO fuzz has a couple different options. We actually really need to clean up kind of all these option things. But effectively, I can do a conversion. So what that does is it converts a snapshot that you took kind of anywhere on your system, and it converts it for a Unix environment. So the box snapshot files have line endings depending on your system. So they will use CRLFs on Windows, and they'll use just line feeds on Linux. So what we do is we have a conversion process where we kind of convert it to the Unix state, and then we run a keyframe on it, and that will convert that snapshot into a keyframe. And a keyframe is an in-memory representation of the entirety of box. And what that allows us to do is, instead of having to make a bunch of modifications to box itself and learn where box stores all the state of all the devices, we just treat it as one big opaque blob. We treat it as just a big block of memory, and everything that is inside of box's address space will end up in this keyframe. And we do all of this through a Unix emulator. So basically, in the conversion phase, we're just converting like line endings and kind of moving that directory, that snapshot directory from box. And then keyframe will actually start this box executable in here, which in Franzia. And this box executable here, if we look at it, we'll see the 7F elf. This is actually a Unix built version of box, and specifically this is a statically compiled with a custom libc. And what this allows us to do is we made some modifications to libc that anytime box wants to do a syscall, instead of doing an actual syscall instruction and invoking the kernel to interact with the kernel, instead it does a call to us. So if we take a look at shared Unix emu, we'll find in here we have basically a way that we can handle all these different syscalls. So this is a Linux emulator here, or a Unix emulator more specifically, and everything in here is designed to be deterministic and serialized and reloadable. So here's kind of this Unix emulator state. We have a fake VM, which contains like the register and address space of a box that we're of the whatever application. At this level, it isn't box specific. Thread ID, the current time that we return to the guest is in quotes because it's a spoof time. We don't want box to actually get a real time because that would cause it to kind of hop around. File descriptors, we kind of have to keep track of all these mappings and things that in this case, I always call it a guest because we're kind of like emulating this process. But that's it. It's really simple. It's 2,300 lines of code. It's actually a lot less. We added some socket stuff, but it's pretty simple. We go through and like fork we don't handle at all. We don't need to handle fork because it's not used by box. But let's look at like a good example of what something looks like. Here's like the open handle. So box directly will do a syscall, and since it's using a custom libc, that syscall has been replaced with a call. That call will end up with this function getting invoked, and then we just grab these arguments, handle everything. We treat it as if we're a kernel, and we kind of handle these things. And what this allows us to do is it allows us to use a static, fixed thing that we have large amounts of control of. Specifically, box has no access to the kernel, and if box has no access to the kernel, we're not able, if box has no access to the kernel, that means as long as we don't give it any entropy, it can't be non-deterministic. And more specifically, we go into some things and we make sure that box doesn't do any direct entropy CPU instructions. It doesn't do an RDTSC. It doesn't use an RDRAND. It doesn't get weird processor state that would change. And then we always put it at the same address. Our allocators are deterministic such that it gets the same addresses for all the M maps, so on and so forth. So we're able to run box and whatever is in it with byte level, instruction level determinism every single time we run it. And since we're running the entirety of box with full determinism, that also means that the guest inherits that determinism. So that's kind of the long and short of TKO fuzz. That's kind of how it works. But other than that, TKO fuzz provides code coverage and all these different things. And we're able to basically develop a plugin instead of actually making a whole fuzzer and figuring out how this coverage works and handling inputs and handling mutation and generation and weighting these things and everything that goes into it. This is what we actually end up having here on this bottom right corner. So we end up writing a plugin that uses libTKO, and all we do here is we kind of create our fuzzer in this environment. So we initialize. We say that we're interested in these callbacks. We want a callback when a generation needs to occur of an input, when a mutation of an input needs to happen, when we need to inject that input into the guest, which is basically the last thing that's done before the VM starts running. An agent callback that allows us to interact with an agent in the guest that allows us to read and write files and launch things. And then CPU ID, which we use to make a rekeyframe. So in here, all we have to do is just implement these functions to do whatever we want. If I just move this over a bit, we'll see that CPU ID, if we see this magic CPU ID number, which we have an application in the guest that causes a CPU ID to occur, we make a new keyframe. And specifically, if we take a look at the calculator code that we use, set GFN 18, nope, 16. If we take a look at this, what we do is we spin up a thread that will time out in 60 seconds. We create a list of commands. We make sure that the list of commands is actually in memory. We technically don't need this. We had an issue in the previous attempt. We attach to the calculator window, so all of those syscalls that go into finding that window and attaching to it, we do that before we actually take a snapshot. And then finally, we end up invoking the CPID with this specific register state that has passed up this command buffer all the way up to Franzia outside of the VM to tell it where the command buffer that we want to use is. Once that is done, all we do is we just send these commands to the window in question. So this means that we handle all of the corpus, all of the inputs, all of the activities outside of the VM such that we can have TKO fuzz handle this for us. And that's it. Once it's done, we return out. Once this application exits, that will cause an agent callback, which will cause us to restart a new fuzz case. So we'll take a look at that. So here's kind of the generation routine. Here we just need to generate kind of a list of commands to send to the calculator window. In this case, we take a Franzia object. That's kind of like the whole emulator setup. We have the input that we need to now generate. So we need to clear this input. That resets it, basically deletes the input. Then we're going to get a list of these known identifiers, which with another application, we use this to kind of find all of the different UI elements that are part of calculator. Once we did that, all we do is up to a maximum number of commands, we generate a random identifier, and we add that to the input list. Then we have a mutate callback. This is going to be passed in input that already exists. So we're going to deserialize this into U32s because it's U8s. Then we're going to randomly corrupt up to 4 of the activities or of the identifiers in that command stream. And then at the end, we're just going to reserialize that out to the bytes and make sure that that gets updated in place in the original input. What's really cool about this model is we don't have to worry about saving these inputs on crashes, on new coverage. We don't have to worry about feeding them back. We don't have to worry about selecting random ones. That's all handled by TKO for us, and all of that information is synced locally, synced over the network. So if you have 1,000 fuzz jobs running, all of them will be updated automatically behind the scenes, and you don't have to worry about that at all. It's a really convenient environment to work in. Then we have the inject case. This is always going to be specific to your target. This is the rekeyframe thing. This is basically, we took a snapshot right when the agent launched on the desktop, but what we want to do is we want to take another snapshot once this application has executed all the way up to this point. So this rekeyframe allows us to make a new keyframe, which basically allows us to start fuzzing directly at another point in the future, specifically this location right before we're about to send these commands to the calculator application. So basically, that's kind of what we have here. Here's where we handle the injection. So that calling convention that we had here, where we pass through where these pointers are, where this command buffer is in memory in the userland application. We're aware of that in our fuzzer, so we grab those registers out. We go in and we get the current fuzz input, which Franzia has correctly provided us an input by this point based on the mutate and generate function, so we don't have to worry about that. We're just going to grab the input. We know that we created it at some time in the past. Then we just go through, this is just kind of handling the serialization. We write in this command buffer directly into the guest's memory space, and then we write in the number of command buffer elements that we actually filled in that buffer, and that's it. And then we register that if this application crashes, this CR3, so this is like a process identifier more at a CPU level, we say that if a crash occurs in this process, which happens to be calc.exe, we want everything to reset. We want it to start a new fuzz case. And then the agent callback is just to handle interacting with that agent in the guest for writing files and executing things. So here, after the write succeeds, we launch the fuzzer, and then after the fuzzer finishes executing, we print the standard out and standard error that we got from it, and then we queue a new fuzz case, and we say the reason we need to start a new fuzz case is because the case ended. We finished what we wanted to do. So that's it. That's basically where we are right now. What we did is we ran this on 64 cores overnight. We did blah, 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 blah. Where's it at? We ran, not that one. We ran about 51,000 fuzz cases overnight, which wasn't too bad. We averaged, in this case, it's saying we averaged 1 per second. It was actually more like 2.5 per second or 3 per second. But some of the workers went offline overnight. So this kind of ran with 0 workers for a while, which caused this this performance number to drop over time. It's not a big deal. Just have some bugs we need to fix. So where did that get us? We ended up with 49 unique crashes in calc.exe, or more specifically on the whole system while calc.exe was executing. And if we take a look, all of these should be unique, but I've identified a potential issue that might be causing some duplicates to show up in this listing. These are all still very real crashes, but we're going to go and fix that bug quick, and then we're going to go into figuring out what caused these crashes to occur, and we're going to see if any of these we get control over. So today is going to be a little bit less on the fuzzing side of things. We're probably going to play around with the fuzzer when we get bored here and there, but we're going to focus more on the exploitation side of things, figuring out the heap states of calc. We're going to figure out what can cause allocations, where we can potentially get grooms in. So that's kind of where we are. Everything should be up to speed, roughly, and cool. So Bald But Aerodynamic asks, Box versus QEMU instrumentation. Thoughts? Box is much better for instrumentation out of the box. It has like a header file that you're able to hook almost any event that happens on the processor. So you're able to hook memory accesses, you're able to hook different weird CPU MSR sort of things, different register writes and reads, page table walks, you can hook weird exceptions. Kind of everything is just built in already in Box. But more specifically, the reason that we went with Box over QEMU is because Box handles virtualization emulation. So Box can emulate both VTX, which is Intel's virtualization extensions on its CPUs, and we can also handle the virtualization extensions of AMD. What that means is we're able to run Hyper-V or Zen or KVM or whatever your hypervisor of choice is inside of Box, which means we can fuzz a hypervisor deterministically with coverage, with feedback, snapshot going, back and forward, so like time travel debugging of that whole environment. It's hard to beat that. It really is. So that's kind of the setup that we have. So, all right, let me see. We got a couple people have followed. I think Hobo Danger, I think I read that one off. Snoozer has followed. Welcome to the stream. And Whitley Stryber, yeah. So thanks everyone for tuning in. I'm gonna try and make this a little bit more interactive than typically I've done. I've got like Streamlabs set up and I've got all the notifications coming up. I'm kind of excited. So, hey 2D, how's it going? Or Hex 2D. Saw the live stream fail and I pogged at the nerd stuff. Well, we do really nerdy things in here. We do a lot of really weird development. Right now we're kind of deep into finding bugs in Calculator. But of course, we're gonna do a bunch of nerdy things in the future. We do hypervisor development. We write OSs all the time. We do systems programming. We do a bunch of different things here. So thanks for tuning in. All right. So we've got all these crashes, and basically the issue that I've identified is that a lot of these crashes are actually in Calculator, but they're showing up in help pane. And this is a relatively difficult problem in gathering code coverage, which is trying to detect where all of the code that has been executed during a specific fuzz case, or doesn't even have to be a fuzz case. Welcome, Code Rifter. Thanks for following. So basically, when we're doing code coverage, what we have to do is we have to generate the coverage in a way that it's module plus offset. If we do not track coverage in module plus offset, that means things and applications that perform JIT, where they basically create a read-writable executable buffer in memory, fill it in with code to execute, and then execute that code dynamically. Those sorts of things would end up appearing to execute at any location in the application. So, and that would cause coverage to basically converge to infinite. You would end up having almost every address have something executed out of it, all kinds of different byte offsets, and you wouldn't really get any meaning out of that information. If you know you're fuzzing an application that doesn't JIT, you can maybe relax that a little bit, but that can be tough to tell. You don't necessarily know if the OS is JITting something behind the scene. So, in this case, what we do to make sure that we always have relevant coverage information is we actually use module plus offset coverage. So every time we get a coverage interaction, we have to enumerate the module list to determine what modules are loaded in the context that we're executing in. Then we have to find where the address that we're executing belongs in that module and calculate that offset. Now that sounds like it's not a hard problem, and it really isn't. Enumerating those module lists is not too difficult. We're going to go into kind of how that's done. But what is exceptionally difficult is doing it fast. Keep in mind that we are running 64 VMs emulating about 100 million instructions per second each. Basically, we're doing like 6.4 billion instructions per second. So we have to be able to resolve a module and offset a couple billion times per second. And that is where it becomes a very difficult problem. So to do this, we want to have a caching layer. We want to have inputs not. We want to have these module lists not have to be rewalked every time. So looking up where something is in the module list is not too difficult. We're able to do that with just a binary search. However, it's a lot more difficult to generate that module list because we have to figure out where the modules are in the guest, and that's a relatively expensive operation. So we're going to hop over and show you kind of how that module offset parsing stuff works. just jumped in. How do you generate inputs to calc.exe when fuzzing? Simulated mouse and keyboard. So we've written a couple things now. On the first stream, we did mouse and keyboard events. The second stream, I think we did mouse and keyboard events. And then yesterday, we just switched over to a new model where instead of doing mouse and keyboard, we actually send these command packets. We do these, this is the actual fuzzer. We send commands, which are just random U32s. And if we take a look at what that ends up doing, this is going to send a send message to the calculator window with the message type command. This is the WM_command message type in send message. And basically, we send this command to the application, and this command can interact with pretty much any element. So most GUI applications in Windows will register for each button, each text box, each menu item. They'll assign like this command ID. So we have another tool that we wrote, and we can hop into that quick. We have a, we don't want to be in dev. So we wrote another tool, which was, I think, calc state. And this application, the goal of this is to try to enumerate all of those different IDs. So what this application is going to do is it's going to delete the calc registry key to make sure that calc always starts in the same state. We're going to launch a calculator instance. And then what we do is we enumerate all of the menus. So that goes through kind of, if we look at calculator, that's going to go through and it's going to try and enumerate all of these menu options that exist recursively. And it's going to log those in a database of known identifiers. Then we're going to enumerate all the sub-windows, and sub-windows will include all of the buttons and text boxes and dialogues. So what we did is we ran this application for a while, and then it will randomly interact with those things. And this is not the fuzzer. This is just designed to get to explore all of the different GUI options available in Calculator. So we run this for a while, and this will go through click buttons and do things in Calculator to switch modes, which will cause new buttons to show up, and then we'll track that those buttons and menu options have shown up, and we eventually create this list of unique identifiers of different interactions that are possible with Calculator. To then fuzz this, we just generate a random set of these interactions. So we can make the fuzzer a lot better by being state aware, for example, knowing what buttons are available in which modes of the calculator, but we don't really care about that too much. We kind of are just letting code coverage figure that out for us. It'll hopefully reduce down some of that noise, but it allowed us to make a really clean fuzzer. And clean fuzzers sometimes are better than complex fuzzers, as you can kind of understand the ramifications of what you're doing more, and the state space of what is changing in the application is much lower. And that just makes it easier to think about it and improve it and reason about what you're doing. So yeah, that is how we generate the inputs currently for Calculator. I'm sure we will be changing this over time and improving it and adding more events and interactions. But yeah, that's what we've set up. We should put a fuzzer definition in the info section below. Yes, I absolutely should do that. I will try to remember to do that. I'll make a note of that. I don't want to do that on stream because that's a little boring, unless people want to come up with a good definition for fuzzer, but I'll make a note. Fuzzer def in info. But I have no issue answering the question of what is a fuzzer 50 times a stream. I think it's really fun that when people ask questions that you answer those things, rather than say, oh, we mentioned that a while ago, because they probably weren't here. If they were here, they would have heard it. So that's kind of what we have set up. So we're gonna hop back over into kind of how this coverage is generated, and I can actually show you all the way into the box side of things what we do for that. So since we're running in a full system emulator, we're emulating all of the instructions as they come across. And what that means is we're able to simply intercept all of these transactions. So if we look at box source, then if we look at instrument, and then I think stubs, maybe, it might be this one. Let me just RG for Franzia here. RGI for Franzia, oops. And it looks like stubs instruments.h, so that was the right spot. So in here, this is kind of how you do hooks inside a box. So what we've done is we have created this perform coverage function. More specifically, it's a define in C. And what this is going to do is this is going to execute every time a branch is taken or an instruction is executed. And that is actually a tunable that we provide to you in TKO fuzz, shared VM source, I think in here. So maybe we actually do it in Franzia. Coverage mode. Yeah, so what you're able to do in Franzia is you're able to configure the coverage mode between different modes. I think that's really important because some people have different requirements for different coverage states. So in this case, this is in the SP shared libtko source, and boxvm, and we'll see that the different coverage modes that are supported currently are none, which doesn't capture any coverage, instruction, which captures coverage information on every instruction executed, and then branch, which covers each branch target. That allows us to kind of reduce the amount of information by about 5 to 6x, and thus the performance overhead of this coverage gathering. Obviously, we want to give you full control of switching between these different modes, because if you want to do it, it's on you. And I think that's really healthy. I don't want to control kind of the way that you do your development or fuzzing, because everyone has different needs. Everyone has different ways they like to develop and get their information. So do you use page heap gflags or some custom memory sanitizer? So I pretty much always use page heap on Windows, and then on Linux I will use electric fence or asan or valgrind. I kind of use all of them. It really varies based on the environment, what I do. However, there are a lot of times where I don't want to use page heap or any of those sanitizers. Sometimes actually today is a good example. When you get to the point that you want to figure out how the bugs you have can crash, sometimes you want to turn those things off such that you can see what are the ramifications of the invalid accesses they're doing. What happens when they do read outside of that buffer? Do they end up using that to look up a VF table and get execution? Do they only use it as an offset into reading something? And that will kind of give us a quick idea of the ramifications of a certain bug. So I kind of turn on and off those options all the time. I'll typically have a snapshot where one is configured with page heap and one is not. If we're using box, we could potentially add a custom fence allocator out of Windows. Yes, absolutely. So I've done that many times before. Actually, all of my vectorized emulation work, since it's emulated, I make my own custom sanitizer. So I will put hooks. You have to be obviously aware of where the allocations and frees occur, but I will actually take control of those, and I will give those allocations out at fixed addresses, and I will truncate them to specific byte granularity. So the vectorized emulation work that I did is actually, it's quote unquote better than asan, but effectively what that means is what asan does, and we can pull up Notepad quick to make a demonstration. Let's say we have a heap allocation here, and this is the start of your allocation. Apparently my fingers are shifted over on the keyboard. So this is kind of your allocation here that you made. So this is the address that malloc returns this, and then page heap or asan will know that this is the end of allocation. And what it will do is it will update a data structure to say, let's say that this right here is an 8-byte boundary. And basically everything that page heap does, or everything that asan does, and this might be dated information. It's like a year old. I think they still do it the same way, but just in case, I'm just going to preface it with this might be dated information. So let's say that this is an 8-byte boundary, which means that this allocation ends on, so this is 8, this is 1, 2, 3. So this is, add some of these, like my diagramming here. Really high quality. This is a address, ends in an OX3. Technically, it's an 8-byte boundary, so it could be like anything mod that, but let's just say that that address ends with an OX3. So this allocation, due to the physical requirements of processors, everything is going to be aligned to 16 bytes, mainly so you can have like XMM accesses aligned out of heap allocations. So now we have, let's just say we have like this remaining stuff, and this is the, we'll say that this is the end of 8-byte aligned chunk. I think it's done on 8-byte boundaries. So what asan will do is it will make a note, and we'll do this. So asan will make a note and basically say that in this location in memory, there are 5 bytes that are not valid. So effectively, instead of actually saying individually which bytes are valid and which bytes are not, instead it kind of treats this as a chunk and then has a remainder which says that 5 bytes are valid remaining after here. So that means that there's no way for asan to punch an arbitrary hole. It can't say that this O is now a valid address. Instead, it has to basically only do like 8-byte aligned, maybe a 16-byte aligned, I think it is 8-byte aligned chunks of validity. And each chunk can basically say the whole thing is valid or n bytes are valid, and that n always starts from the start or the lowest address in that chunk. So what I mean when I say that the vectorized emulation stuff that I do is quote-unquote better than asan, it's not because it really produces any different results, but what I do is I have a permission byte for everything in memory, and that means that all of these have separate permissions, which means that I can punch a hole right here, and this 1 byte is valid. And asan does not have that ability. It can only punch a 1-byte hole in something if it is aligned on an 8-byte boundary. So that is just a little example of kind of how asan works. This is from memory, so if this is something that really interests you to understand these deep internals, please go seek that out yourself, because there's a little bit of noise when you do things from memory like this. So there's a chance that this is outdated information or things that maybe I got wrong. Maybe it's not 8 bytes, maybe whatever. So if you are interested in that, I actually blogged about my MMU, MMU design. So I have a whole blog of how I implemented, that's the localhost version, github.io. So I kind of go into in-depth how I implement a MMU designed for catching as many bugs as possible in an emulator environment. This is a lot more complex because it's vectorized emulation, which means we're running 8 or 16 VMs per core, which makes it really sophisticated. But I kind of go through like how I set this stuff up in memory. I talk about the performance ramifications. I talk about deduplication of pages and how I can reduce memory costs of some of these operations we're doing. But I go pretty deep into this, and then also I go into the performance and what this looks like. In fact, I might have made an implementation public, but I have all the performance of basically how quickly I can read and write memory in these emulators, because that's really important. Vectorized emulation is kind of the top of the line fuzzing work that I do. I haven't really done it on stream. It's a really difficult problem to talk about because I don't even understand it yet. It's still research that I'm working on. But effectively, the net effect of vectorized emulation is probably the fastest fuzzing in the world by probably an order of magnitude. So I fuzz things like Windows DHCP at like 16 million fuzz cases per second on a single server. I fuzz like a firewall thing in Windows at like 770 million fuzz cases per second. So it's an extremely fast fuzzer. In fact, the stuff that we're doing today, where we're seeing like 1 or 2 fuzz cases per second, is a much different approach and way of doing fuzzing than I do fuzzing nowadays for really hard problems. This is more approachable. Box has about 100 times performance penalty. So when we see that we're getting, where is it? Like 1 fuzz case a second. If we had this on a bare metal hypervisor in a much more performant environment, likely on the exact same hardware, this would run at 80 to 100 fuzz cases per second. However, the determinism and the reproducibility is worth the performance loss. I can tell you that as someone who probably has the fastest fuzzing tech in the world. I can tell you that reproducibility and usability is leagues more important than perf, especially in the order of two orders of magnitude, which is not 2 orders of magnitude for a fuzzer. For a fuzzer is not a big deal at all, because your fuzzer is likely so inefficient that 100x code execution speed up still is not a big deal compared to the amount of inefficiencies and bad inputs that your fuzzer is generating. So I hope that answers your question. Okay, is fuzzing something you do for a company, or is this a hobby project? I just basically always do fuzzing, but I do work at Microsoft, yes. So, all right. Okay. So, in the instrumentation inbox, this is kind of a hook that we add on every branch or every instruction boundary. And what we do here is, so since we're running box inside of this Unix emulator, we have to be able to kind of keep a different, we have to keep kind of a different state between the Franzia application that's running and then the box that's running under it. So we have to do a context switch. It looks very similar to like OS development context switches between threads. So when we break out a box into Franzia, that we call that an fcall, a Franzia call instruction. So basically, this will end up causing all of the register state of box to get saved, which is a relatively expensive operation, and then all of the register state of TKO fuzz to get loaded, and then we continue execution in TKO fuzz. So what we want to do is we want to reduce the amount of fcalls that we do into Franzia. If we're doing a boatload of fcalls, we end up in a situation where we get stuck kind of on this boundary. And this boundary we can say is approximately 300 to 800 cycles, depending on the processor you're running on, which is not a big deal. You can comfortably do it a couple million times a second, but we want to reduce that if we can. The more we reduce that, the less our overhead in TKO fuzz is. So these are all box-provided hooks that are put all over the code base inside a box. We didn't have to do that. Box did that for us. And this allows us to get access to different things. So here's a near branch, which is taken, a near branch, which is not taken, an unconditional near branch, a far branch. This happens every time an instruction executes. And in these cases, what we want to do is, if we're in a specific coverage mode, branch coverage versus instruction coverage, we want to call this perform coverage define, or use this inline this perform coverage operation. And what this is going to do is it's going to see if these coverage maps have been initialized. And they're always initialized, but we do this just in case there's a bug. This is something I encourage almost any developer to do, especially when working with unsafe code. Put in your damn asserts, and don't make them debug asserts. Make them always in there. A comparison like this is so unbelievably cheap that just leave it in there. Leave it in your release builds. Leave it in things to catch these issues. There's no reason to remove 1 or 2 cycles out of an operation that happens even a billion times a second. It's not that big of a deal, especially in your GUI application or your web application or your Electron app. These asserts have almost no cost. Leave them in your release builds. So here we're going to calculate a hash, and we're doing this kind of based on a Azure shift. This hash is really low quality, but the goal is we want to quickly, remember this happens hundreds of millions of times per second per thread. So what we want to do is quickly shuffle in the address that we're executing, this PC. We want to very quickly increase the entropy of it. So for example, PCs, when you're executing code, will typically follow a traditional pattern. So if we're executing code in this dead module, we execute an instruction at offset 3, then at 4, then we have a multi-byte instruction, and now we're at 7, and now we're at 10. Actually, that's a huge instruction. But you'll see a stream of instructions like this. What's difficult about hashing this is that you're going to see so much commonality in the low bits of these addresses. So what we want to do is we want to make sure that some of the high bits that are not going to be used for indexing this cache get shuffled into the low bits. And we do that through one iteration of XOR shift. It's really low quality, but we don't really have the time to do anything more. So we take the address, we XOR it with a completely random number. This is a basically free operation, but this makes sure that address becomes a much higher entropy integer. And then we shuffle it around. So this will kind of cause some of the top bits and low bits to get shuffled around and cause like this new hash to be created. It's a terrible hash, but once again, we don't have time to do a good hash. Then what we do is we look up kind of in these different coverage maps, and these coverage maps are filters. So we're basically filtering at the box layer things that we report up to Franzia to reduce those fcall overheads. So here we're going to take this hash, we're going to mask it with the number of entries in the L1 table. We always make sure that this is a power of 2. More specifically, like a exact power of 2. I don't know how to, power of 2 I think describes that perfectly. Then what we do is we look up this index in the map, and since the same PC will always generate the same hash, what we do is we see, is this value in our cache? And if it is not in our cache, or the cache has been updated, so basically invalidating this cache is very expensive, so instead of clearing out this cache by zeroing it out or something, we actually have version controls on the hash, on the cache. And so what we do is we check if the version of this cache entry matches the version of the coverage table. And what that means is that we can invalidate the entirety of the cache by writing a single quad word to this address. And it's just really convenient, and that it provides a way to invalidate very cheaply. It means we have to do a runtime cost where we check it every time, but this is much, much cheaper than if we were to end up actually invalidating that cache entirely on each new change of this coverage version. We then do this again for an L2. So we have an L1. This is meant to be a much smaller cache to fit specifically in the L1 cache of your processor, such that we can very quickly determine, have we reported this PC very recently? And then, if we haven't reported that PC very recently, then we look in a slightly bigger map that's still relatively small, so there's still going to be duplicate reporting up to Franzia, but that's fine. Here we're going to see, has this been changed a little bit more recently? So now we're looking kind of from that perspective. And if both of those fall through, that basically says, okay, we do not have any indication that we have reported this coverage information up to Franzia recently. And recently is probably on a window of like a second of execution time, but that's plenty. That's plenty to reduce the amount of fcalls to a reasonable level. And then we perform the fcall, which is an expensive operation that will cause Franzia to get invoked, and we're basically telling Franzia, hey, we have something that we want you to look at. And that's it. The ending part of this is just filling in those maps as with an updated version of what we have done, such that if we hit this again, so on and so forth, everything's good. So this is really just a quick filtering operation to reduce the amount of times that we perform fcalls reporting coverage. Given that this coverage version is modified every time a new fuzz case starts, you will never miss a coverage event. Since everything is, well, technically, since things are done by PC here, if you have things executing at the same PCs in different modules, it's possible that this does filter them out. So to get this to be perfect coverage, and perfect coverage is very difficult at system level, to get perfect coverage, what you would want to do is when CR3 changes, you would want to update this version to invalidate the cache. So every time you end up in a new process or a different address space, you would invalidate this cache. To make that even more specific, you would want to actually know when modules are loaded or the address space changes in an application, and you would want to invalidate the cache on those transactions as well, just in case a single application unmaps something and then remaps something at the exact same location. But that's effectively how we do the filtering at the box level. We're trying to do as little modification to box as possible. The fewer things we modify in box, the easier it is to update box to a later version when we need those changes. So if box upstreams some fix, we want to be able to merge with it as easy as possible. So we've gated everything by if-defs, and we've tried to make as few modifications to box itself, and we do all of our analysis in Rust in more of the Franzia TKO fuzz side of things. So we can now hop over, and we can see what happens. So with that coverage information. So here, this is where we actually go to run the Unix VM. So here we're saying, I want to run this Unix VM, and we pass it some statistic structures such that we're able to keep track of how much time is spent inside of the VM and how much time is spent handling syscalls. This allows us to keep track of the overhead that Franzia is imposing on the guest. This kind of lets us see, are we using 1% of CPU time to handle stuff? We basically want 100% of CPU time to be spent executing inside of box. Any time spent outside of box is code that is not being fuzzed. So I keep track of a lot of these statistics throughout code that I write to try to figure out roughly where we're spending our time, because I know this number can be quite low. So here we run the Unix VM. Once that VM returns, what we're going to do is we're going to take that box state and we're going to sync that with the Franzia state. So we're going to rip out all of the register and information that box has, and we're going to place that into Rust structures that we can work with at a higher level, a little bit easier. Here we're just updating iCount, I guess, here. Yeah. And then down here, we handle why did box exit. So basically, box will run forever. Any Unix application will run forever under this environment until something happened. And it could be a syscall, it could be an fcall, whatever. So the Unix emulator actually internally handles the syscalls. So when syscalls happen, they happen inside of this function, and we don't have to see them here. It's meant to be a little bit of an abstraction. But what this can do is it can tell us that there is, let's see. I feel like for some reason my desktop audio also has my voice. And I don't know if that's making audio really weird, but it looks like maybe it's echoing back. I have everything closed, I think. And I don't think this preview would play audio. So, not quite sure there. But I hope it's not a big issue. Anyways, so this is going to handle syscalls internally. At the end, we know that box has finished executing, and it wants to do something other than a syscall. So either box has exited, box has crashed, or something has happened in box. So what we do is we check why did this exit occur from this Unix environment. And we can see if there's an exit code, we just say box has exited. If there's an error, we try and figure out why there was an error in executing whatever we did. So in this case, we see that we can see, is the reason that this VM exited due to a syscall which was unhandled? And this is where fcalls happen. So fcalls, at the end of the day, are actual syscall invocations with magic numbers that aren't conflicting with the numbers that normal Unix syscalls use. So all we're going to do here is we're going to mux these out and see what happened. So you'll find that one of these is going to be coverage. So if we perform that fcall, which we saw that fcall invocation, and we had this coverage invocation, we're going to jump into the fc coverage function. And the fc coverage function is basically telling us new coverage event occurred. Something happened in box that we haven't seen. So we're going to take a look at this. I'm going to get up to date on kind of follower notifications. So it looks like Complexities has followed. Thank you for following. RadoBot has followed. Thank you for following. And DevilRay_EX has followed. So thank you everyone for joining in on the stream. I hope you're having fun. So it's amazing how you explain everything well and take the time for everything here as we ask you. What you teach is more valuable than any bug itself. I absolutely agree. And that is something that I didn't realize until like a year ago, that the amount of stuff that I can do as an individual person is much less than anything that could be done with people who learn from the things that I do or benefit from the tools that I write. So I'm not the most social person. I will often find myself sitting at home writing code for weeks at a time without leaving. But that can benefit people too. You know, when I'm in the mood to get on a stream and talk with people and share these things, I want to teach. I want people to ask questions. I want people to ask hard questions. I'm not trying to look cool here. If I do something stupid, I have no problem owning up to that. If I make a mistake or a typo or a bug or I say something incorrectly, I have no problem with people saying, "Oh, that's wrong." I do have problems with people suggesting things that make no sense at the time just to like promote conversation, but hey, a question is a question, and there's a I really don't think any question is too stupid as long as it's genuinely asked, and that's something that I'm starting to realize. It's starting to become like a more social thing that I'm starting to follow. That basically, when someone asks me a question, I kind of go with my gut instinct of whether or not it came from a genuine place. And that's like a really hard thing to quantify, obviously. But you can kind of tell when someone is asking a question just to engage you in a conversation, or like to vent about something, or maybe to nitpick, or maybe to even subvert something you've done by trying to ask a question to try and poke a hole in something you're working on. And there's a difference between that and when someone asks a question that you genuinely can tell excites them, makes them like happy to get an answer. And those sorts of questions, doesn't matter how stupid they are. You know, when someone asks, "What is fuzzing?" as long as they're asking that in a meaningful way of genuine curiosity, I don't care how many times I answer that question, because I know that someone is going to learn something that they wanted to learn from that interaction. So that's kind of the direction I'm trying to go. I think streams are really fun because everyone here is by choice. Everyone here is here in their free time. Whereas if you were to give public trainings or talks, while a lot of people are there because they want to be there, a lot of people are there because maybe their employer required them to get training. Maybe they're trying to use the training to leverage it into a better position at their job. Maybe they're trying to do those things. And those are great ways of improvement, but I'm more interested in people who are genuinely interested in expanding their knowledge and enjoy what they're doing. You know, I don't want to teach people who are using the teachings to then recite in an interview to get a better job offer or to get a different job offer. I want people genuinely who enjoy doing this sort of work. So that's my mini rant there. Okay, we got Holodalo has followed. Thank you so much. Welcome to the. I need to make a name for whatever this. All streamers do the thing where they have like the name of their people. So I could maybe start doing that. Anyways, so all of that filtering has happened inside of Box, and now a coverage event has bubbled up into TKO, indicating that there's something that we need to look into. So here what we're going to see is if we have a special coverage version where we want coverage kind of disabled, but in this hybrid state, we just return out and do nothing. That's not the state that we're really ever in. Then we want to get the program counter. We want to get what is currently executing. And in fact, I actually made a commit that I think changed this sort of stuff. So I might see if I can PR that change in, because I changed how this coverage stuff works. And if we're going to be going in and making changes to coverage, I need to make sure that we have done this on the in the right environment. So git status should be on mageweave MMU. Git diff. I'm just going to quickly figure out what we did here. We added a page cache, and I think that's it. Git commit am added page cache functionality to server mode. And then what I'm gonna do is I'm gonna pull in the I'm gonna merge in from master. Let me actually check out what master looks like right now. There shouldn't be. I don't know, it's hard to say if people dev'd on the weekend. Git checkout master, git pull. Let's get that up to date. Git checkout mage weave mmu, git status. And then we're gonna do git merge master. So we got some conflicts. I'm not too surprised. We're working with a pretty massive rewrite. So previously, TKO fuzz only worked locally, but I've added all of this network scalability to it. And this has changed massive aspects of this code base. So I'm going to quickly go in here and I'm going to try and fix these merge conflicts, which might be relatively difficult. So... all right. We really have to do this because if we look at FC coverage, this coverage stuff has changed relatively dramatically, and I need to make sure that we're not fixing bugs in a code base that we no longer support or branches we no longer support. So I'm just going to look for changes that have happened here. We now have a power off interaction. That's fine. We just want both. We have... whoa. All of the memory backing stuff is new. Validate coverage when unresolved. This actually belongs up here. This is actually a relatively difficult merge. I have to think about the ramifications of what I'm doing. Okay, in this state, we have to save the keyframe file name as server address. So that's new stuff. Reset that. Update the internal coverage version. Yes, so we just want both of those. Here, I think we want master. I think we just want master's version of everything here. Yep, that gets the address, L1 and L2 indices, and that invalidates those. Okay. So that should be all merged. We have another merge conflict in KDNet. Let's see what modifications were made here. Oops. Okay. I'm just going to take master's copy of this. Master is just going to be more correct. Anything that we did here was temporary. So we're just going to go with master for this. And then we have a merge conflict on a cargo toml. Well, that's surprising. That's such a simple format. I am really surprised there's a merge conflict here. Master's version is probably more correct. Actually, there are a couple things that have changed shape. So I'm going to reason through these excludes. We want memory state, shared mem, state and mem file, coverage files, the task list file, all the under shared mem files, all the state files, all the mem. We have those. Coverage.star, under inputs and under crashes. That should be good. Get status, cargo run. Okay, not too surprised here. So we have something that has changed a little bit internally. Nothing wrong with that. We can figure out what's going on. Let's just take a look at libtko. I know I have this open in another window, but sometimes I like to open these new windows as I'm figuring out what's going on to make these a little bit more stateful and have undo buffers be separate. So let's see. Add input. It takes 2 parameters, but 1 parameter was supplied. 2848. Yep. So add input. This needs to take in the whether it's in client or server mode, and I think we put that in self.client mode. I think we have a function. We do. So that should just work. 2861. This is not happy with filling in this coverage entry. It expected an extra U128, and which means that we added what did we add here? So this is in coverage list. Shit. Covers list len. See if I can find. It tracks the input hash. So we make a comment when we have to reference code for something that we did. That's always a sign that you don't have good enough comments. So this is going to be tuple is module hash, module offsets, time date stamp of module, image size of module, and the input hash. Now we don't have to reference code again to make these modifications, and what we can do is we can go up here, and we now know that this fourth element that we've added is indeed the input hash. And that's it. I think we should have resolved all the merge conflicts. Looks good. Git commit am fix merge conflicts. Nice. We're going to push that up just to make sure that we don't lose this in case something happens locally. You never know. Okay. Clear the history. Now, there's a couple things that I want to change. Since I know that this that the boundaries have changed on some of these fields, I want to go into box, or actually sp source, actually shared lib TKO source. So I was using VS Code for a while, so I don't have my tab complete muscle memory kind of set up, so I'm tabbing a lot of the wrong things. That's something we'll try and fix. So this is the TKO fuzz version. This defines the versioning in the protocol that's used to communicate between box and Franzia. And what we're gonna do, we're gonna ref that a little bit. Random.randint 02 to the 64, and I just use a random number. You'll find in almost all my code bases, I use just completely random numbers for identifiers. Then I don't have to worry about whether I've used one or not. So now what I should be able to do is, if I try to repro this crash, I should get a pretty hard error saying that the TKO version did not match the sync with box, which is good. I'm going to go into, now I can go in and modify box's version field, which I think is just in box.h. TKO fuzz version is probably in here. TKO fuzz version. Okay, I typoed that, but I'm just going to RG here. We're going to search for, version's not going to do it. TKO fuzz version. TKO fuzz version. TKO fuzz. Just going to scroll around. We're going to try and find, and then we'll, let's actually look for define dot star. Okay. I mean, this just tells me that it's in cpu.cc. That's why we write comments. Version. Okay, TKO version. And we're just going to replace this with the new one. And stuff will still not work because we haven't updated these keyframes. And the version number is actually stored in the keyframe because it's in the memory of box. So what we're going to need to do is we're going to need to rebuild box. So I'm going to go into whistle, actually cd dev TKO fuzz. Actually, we're going to go into the root directory anyways, cat build.sh. That should build everything there. And Franzia box build. We're just going to remove everything. It's pretty cheap to build Franzia, or to build the custom version. So then we're going to do a source of build.sh, and this should go through and build the box executable that we use for TKO fuzz. All right. Anyone have any questions or anything to say while we're waiting for this slow build? All right, that build is now complete. We now have a new box executable. And if we look at it, it's a statically linked file. So I'm going to do a copy of that box executable. Actually, the build script that I have might do that for me. No, it doesn't. Box to mount d dev TKO fuzz franzia. So now we have updated that box executable. Everything should now agree on the FFI boundaries. And what I'm going to need to do is I'm going to need to regenerate the calculator keyframe. So we're going to go in and dir fakefs cargo run keyframe this to calc. So we've now created a new calculator keyframe. Just got to wait for this to finish. And then we're going to have to generate that keyframe by setting the rekeyframe option in our fuzzer true. So this will create a new keyframe from that environment. Let's see where are we at here. What are we waiting for? We don't need this, don't need this. We'll keep that KD session around. Keep that open. So we're just waiting on this. And then we're just gonna run this keyframe, which will cause it to hit the breakpoint once we've injected our application into it. So the reason this is slow is Box actually loads up all 8 gigs of memory. We would have to modify Box to not do that. And we just haven't really bothered to do that yet. That's a modification of Box. And anytime we modify Box, we have to worry about the ramifications of what we're doing. So now I can do cargo run start calc. This will start the calculator in our fuzzer, and it should produce that new calc stepped. And now we should be back in business. Now we've rekeyframed, and I only guaranteed determinism between keyframes. But I think rekeyframing should actually be deterministic. Calc stepped copy. We're going to make a copy of the calc stepped. And that allows us to kind of run these tests in a slightly different environment so we don't end up clobbering the coverage information from these long runs. So we're going to just copy these 2 files. And oh boy. So we fixed this issue earlier, but there's a chance that the merge made us lose that serialization. So we're going to take a quick look at pending agent command. We're going to see where this is at. So we have the pending agent command, none. Here we serialize it out, looks correct. Here we deserialize it. That looks correct. I'm just trying to look through to see if there's a situation where we might not handle that serialization correctly. So let's see when we go to deserialize this, let's see if there is an issue with what we have. Print pending agent command is this. And we're just going to do this on, oops, I probably should give it the argument, you know, that sort of stuff is useful. I don't think it really knows what I was trying to do there. All right, let's see what happens here. Come on. That looks good. Oh, it's because we didn't set this mode. Yep, we didn't set this back to false. My bad. All right, and we could make that rekeyframe stuff a lot cleaner. And I actually have some users of the tool that are requesting that, so we might actually go try and figure that out. So K special was the wrong size. Yep, that we turned this into a warning in our version, and we're gonna go propagate that change. I'm gonna go into this. Whoa, R. We're gonna turn this into a print. Actually, if this is not equal to this, then we're going to print that this happened. How do we fit this? We'll just do this. Wrong size. Ours was this versus that. Let's put a new line in there. And that should be good. And that. Okay, so now we should be back kind of where we were after the merge, which means we can go in and try and fix that coverage bug. I want to see if this repros. That'd be pretty cool if this repros when we switch keyframes. That's out of bounds, of course. This 327, we have changed. Actually, that might be in source main. Source lib.rs 327. Yes. So reset reasons. We just need to up this because we've now. This goes to a 7. Basically, we now have another exit reason that was added due to the merge. So we just need to update that because we also added one, so needed to up that count. And now I think everything should be working. So, and it looks like it reproed. So we were able to re-keyframe and still maintain that determinism because the way that we load a snapshot in box is also deterministic, which is pretty sweet, actually. All right, so everything is kind of back up to where we wanted it to be. So what we're gonna do is we're gonna look at how we implement coverage. And I know we keep getting sidetracked, but that is what happens in development. We can't always do exactly what we want to do at the time. Sometimes we have to take these extra steps. So we see that now this has kind of been modified. Information is now being passed up by box. It's passing in the address rather than us always using the PC value. That allows us to not use a PC when we had a branch or a situation where maybe that has changed. Thank you, Omen Cat, for following. I don't think I shouted that one out. So thank you for following. Okay. So we have... here we're going to query the module, so we're going to try and resolve that module. And that's where everything is basically going to potentially be an issue. So what I'm going to do is I'm going to see how hard it is to get these crashes to repro. So what I like to do is I like to make kind of another folder where I keep track of everything that I've done. Here I'm going to say crash results, and I'm going to say overnight run TKO fuzz. So we're going to move all of this information as well as the coverage information, which hopefully we haven't clobbered. Hasn't been updated since 7.14, so that should be good. So we're going to grab those and paste them in here. So now we should have all of this, didn't want to scan it. We have all the coverage from last night. And then we also should have all the crashes from last night, and we'll have all of the inputs from last night. And this is everything that we need to reproduce any issues that we had. Technically, we also need the keyframes, but I'm not going to make a copy of the keyframes. We know what the formats of these things are, and we can reproduce them in a new keyframe, so I'm not going to make a copy. If I knew that this keyframes would be hard to reproduce, I would make a copy of the keyframes. I'm just not opting for that right now. Okay. I'm also kind of low on storage. I only have 120 gigs, which sounds like a lot, but if we're making 10 gig copies of keyframes every time we do a fuzz, we're going to end up using that up pretty fast. So I could grab a platter if I need to, if we get to that point. So in here, what happens is basically if coverage got reported up by Box is saying something new has executed that we haven't reported recently, we're going to resolve that. We're going to try to resolve that into a module and offset. And if and only if we can resolve that into a module offset, will we actually go to try to insert this into our database. So what we'll do is we're going to see if there's this ignore coverage in module thing. So this is a filter that allows us to disable coverage tracking in certain modules, maybe modules that we don't care about or that are noisy. And then we go through and we see if we should filter it out. Then we compute this hash, which takes the coverage version, hashes it with the module ID, and hashes it with the offset, and it updates the coverage hash table here. Then we I guess we update that coverage has a coverage increase has occurred. So basically what we do is we try to insert this into the coverage database. If this coverage is already in the database, then we do nothing. So all we've done is we've looked up that it exists, we've had a match on the hash, and we just return out. Otherwise, we say that coverage has increased, which it has. We then add this fuzz input to the database so it can be used in feedback. We create this kind of coverage event entry, so we allocate a tuple of this type. We fill in the module ID, offset, time, date, stamp, image size, and input hash. Then we fill that, what do we do here? Coverage ID. Here we do a fetch add, so we get a unique identifier for this, this coverage, such that we can have a list of coverage and a set of coverage. There's not a fast way that we can pick a random value out of a hash table. So what we do is we maintain both a list and a hash table of coverage. We create, are we inserting that into the set? Hash table entry, metadata. Where are we using this metadata? Coverage event. Where are we using this? Oh, here. Okay. So, I see. So, we create this coverage entry, we put this in the coverage list, and then we make a new metadata structure, which the coverage table hash table refers to with an input ID and an input hash. So we're able to kind of go through and resolve all of that. So we're actually making both an input entry and a coverage entry here. Let me double check this. Something seems a little off here. Coverage list length. Fetch add this. At this location in the coverage thing, put in a pointer to CLE. And then it's coverage ID. Is this ever used? No. So I guess there's no way from the coverage hash table to get the coverage ID. That seems like an oversight, but we do have that information here. I'm not going to add that right now. There's nothing that is requesting that we have that information. So, okay, and then here, otherwise, if we were not able to resolve it, we have this invalidate coverage when unresolved flag. And this is something I added last week. And what will happen is if we were unable to resolve the module and offset for a specific address, and that can happen due to many different reasons, we'll go into in a little bit, we'll invalidate the entries in the L1 map, which will cause that to get immediately reported on the next time that we see that instruction. Then we invoke callbacks on coverage events. And finally, we set that the fcall was successful, and we're all done. So, doesn't look like there are any bugs in this function, and I can assure you that there are not. This function has no issues itself. But what does have issues is query module. And if we look at query module, the way that this works is we're going to take an address, and then we're going to find the module ID, time, date, stamp, and image size. Module ID is just kind of a unique identifier. So instead of working with strings, we work with identifiers. If we were working with strings, these operations would be a lot more expensive. So we're trying to cut down on those things. So here, if shared memory is none, we return out. This is not a state that really exists anymore. This is kind of legacy stuff. We're eventually going to make this no longer an option. If the OS type is unknown, then we return out. So basically, if we have no way of getting the module and offset for this OS, so modules are an OS construct. It's something that exists only in the operating system, and thus we need to have something that we call enlightenment to understand kind of how the guest stores those structures so that we can find that information. So in this case, I'm going to look up in the module list cache, which is kept around forever. You can see immediately a problem here. We're going to look up in the cache. We're going to try and resolve it. If we couldn't resolve it, we're going to do a lot of stuff. But if we could resolve it, we just return out. So basically, if the module is cache, which is not keyed by process and it's not keyed by different states of the OS, basically, if this cache has a valid entry for this address, then we're going to return that as the coverage. And this is likely the issue that we're seeing. So we're seeing that some crashes can occur. That show up as help pane that are actually calculator crashes themselves. And we went through and we reproduced these, and we saw that they were indeed in the calculator process. So the issue that we're likely having here is the module-less cache is not actually, it's not being cleared on a CR3 change, which means that there's no, it's theoretically possible that what can happen is that we can be in one process. So we're in help pane, someone invokes query module. So someone was trying to look up an address, help pane was the current process, so that's what is in the cache, or help pane was the current process when we ran this and it failed. This cache now is in the context of an application which is no longer running or is a different application, and there's a collision between an address in the help pane application and in the calc application. And in this case, there's a situation where help pane is loaded at the same address that calc, or not same address, but they overlap. In some way they overlap, and there's an address that we can query that exists in both, and if the cache is in the right state, we will end up returning the wrong information. So that is effectively what I think this bug is. My confidence is pretty much 100% that this is what the bug is, so we're going to end up fixing this with a quick little trick. So let's take a look at this. This is where we're going to query the module list. So basically, if we could not resolve the module, we're going to go through and we're going to perform kind of these searches through it. So there are a couple things we can do. One approach would be we could have a different module-less cache for every page table in this system, and that would allow us to kind of get a speed up so that we kind of keep the context of other processes around. So that has a performance advantage, but it has a potential collision course, which is if the module exists, or if another process is created with the same page table, the same CR3 value, then there's a situation where we could potentially have the exact same issue we have now if there's a collision on that. And it's hard to say how likely that is. That would basically depend on the likelihood of the operating system to return the exact same root page table page for another process that got created. And I don't know how high that is. I'm actually, I'm not sure. It's actually really hard to say whether that would be common or not. So the other thing that we could do is every single time that the guest changes CR3s, the guest changes that process boundary, we could invalidate this cache. And that would cause us to basically assume that any change to CR3, even if it's not a change, just a write to CR3 to invalidate the page tables, we would invalidate these module-less caches. So let's think about this a little bit. So on x86, if you ever want to update a page table entry, you have to do a CL flush instruction, or you can invalidate the entire page table by writing to CR3. So in theory, I think we actually would have no possibility for a bug if we invalidated the module-less cache when a CR3 is written, or when a CL flush occurs on an address that is present in your module-less cache. So let's see if we can get those correct hooks in here. This will kind of allow us to fix the bug. I know it's been almost 2 hours and we haven't actually looked at bugs yet, but we need to get this up and running in the background. This will help us. While this sounds stupid, a lot of these bugs are misreported to us as help pane, and we could either go through and try and figure out which ones are which, or we could try and get this fuzzer fixed such that the coverage result or the crash results actually are relevant. So we're just going to very quickly do this. We might have to add some enlightenment to box. So fc, let's see what fcalls we have. Fcall power off. Fcall new, so these are raw frames. So we also have a way of writing plugins that allow you to fuzz network protocols. all deterministic once again. We're using those very successfully on multiple Windows products right now. It's actually really cool. This tool is probably the best system level fuzzer I've ever used in my life. And I've had other users say the exact same thing. So I think we have a pretty good thing going here. So if we take a look at these, fcall power off, what I'm going to add is I'm going to add a hook in box. So we need to find in box where CR3 can be modified. And we're going to add a couple calls. We're going to add an fcall when an invalpig happens, which is invalidating a page table entry. Not clflush. I think I said clflush before. Invalpig, invalidate page, and then CR3 writes. And those are the two ways that you can invalidate page tables on x86. And thus, if a module got loaded or JIT happened or any address space change occurred, we should correctly invalidate those things and re-update our moduleless caches. So let's take a look. Let's go into dev, TKO fuzz Franzia, and what do I want? Actually, I want to look at box, and here we need to figure out where CR3 writes occur. I'm just gonna guess that they probably happen in. Looking for something to stand out to me here. CR regs. That looks good. Write CR3. Write CR3 this. Move CR3 RD. That is explicitly an instruction. So this is like an instruction handler for that. This calls set CR3. And let's actually take a look at when TLBs get invalidated, because when box decides to invalidate a TLB is likely when we need to invalidate our caches. So we've got a move to CR0 that can technically change the paging bits and the paging modes. So all of these things, an invalpig, there it is, a context switch and task switch. So what we're actually going to do is we're going to use box's instrumentation directly, and we're just going to search for, that's actually exactly what we just did. So where is that hit? Where's that defined? I don't see that defined anywhere. I'm going to see if we're going to bring up whistle again, and we're going to end up having to add another fcall, and we're going to call it like TLB invalidate. And we're going to use that to invalidate things that we have cached about the system. And this should be like universally applicable to almost every operation. These CR writes are done very rarely in an OS, so they're not noisy. This is going to be done somewhat common. Basically, every mmap will invoke this. Context switches are going to be quite rare. Task switches are going to be quite rare. Invalidate these EPT things as well. So what we should be able to do is we can go into the instrument stuff and the stubs, and we can go into where we implement our stuff in Franzia here. And what I want to do is define bxinster TLB control, and let's take a look at what arguments that took. So it looks like this takes a CPU ID, a what, and a new CR3. Oh, now those show up. Oh, I was in the CPU directory specifically. So now I can look for this. And this is the else case. So just need to see where we are in Franzia. So if def Franzia, there's an else there. So what we want to do is we want to rip this out. TLB control here. We're going to make our own TLB control there. And then we're going to make another here. So this is the if Franzia is not defined, we use these. Otherwise, we use these in Franzia mode. And we're going to work on a little macro here. This is just going to do an fcall TLB change. And I think we have to pass a 0, and I think this is all we're going to need for instrumentation. New CR3, we don't necessarily need to pass that up. Actually, we will, because why not? CPU ID what new CR3. And we're just going to wrap all of these in parens just in case we have some sanitization issues. And then I need to figure out roughly what these are. So I want to figure out what types these are. Val32, Val32, Val64. So that's a 64-bit. That's a... I mean, it doesn't really matter. We're just going to... All of them are going to be 64-bit things. I'm just going to see if any of these don't line up. Everything looks good. So we're going to call an fcall TLB change. We have to define a new fcall for this. So we're going to go into... I think the fcalls we do actually define here. So we're going to make a new fcall TLB change. It's going to be 15. And we're going to make sure that this information also finds its way into this. Pubconst this. And it's a U64. There. Good. So now everyone should be agreeing on those fcalls. We're going to need to, technically we should update the fcall boundary version number, but we're not actually going to do that yet, mainly because we just changed it, and since we're not working on master, I'm just not going to go through the pains of generating a new number for that. You know what? Let's do it correct. It costs us nothing. Import random.hex, random.rand int the 0 to the 64 this one. This is our new TKO version. Shared lib TKO source box VM. Update this version. Then we have to also update this in cpu.cc. I think this is worth it just in case we try and use an outdated keyframe and we end up shooting ourselves in the foot. So this will now fail. Well, this should now fail. Yep. Looks good. That didn't work. Well, I think we might have deleted that file. But if we try to repro calc stepped, that repro file, cargo run start calc stepped. So this should fail. Yep. Doesn't match the version. Then we're gonna have to go build this again. So we'll take this whistle, cd this, cd franzia, source, box, build.sh. Technically, I don't need to run it through the configure process again, but whatever. I'd rather this than figure out how to do it specifically to just the one event. This is almost done. This is going to make it really clean. We're going to invalidate that anytime a page table could be changed. And that will get us all of the rights to CR3. So page table changes, it will get us invl-pigs, which is like emmaps that occur given a specific process. So this is actually going to give us some really good fidelity. I don't think those were my warnings, so I think we're fine. Pretty much everything gets rebuilt when you change instrumentation files, obviously, since those pound defines are used almost everywhere in box. We're going to have to re-keyframe again, of course, like we did before. So copy box, mount d, dev TKO fuzz franzia box. Replace that, and we're going to keyframe again. We'll keep that build session open just in case. Here we'll do cargo run dir fake fs cargo run keyframe this calc. Okay, so that will go through and that will generate that new keyframe. And then we're going to hop on over and we're going to start implementing this. So this will panic. If we were to run this right now, we would get a panic almost right away because we don't have a handler for this fcall. So we're going to add an fcall handler for this, self.fc tlb change. And then we're going to go to fc power off. Okay. We'll just put it right next to power off. Function this, mute self, called when the guest has done any operation which may modify page table states. This includes writes to CR3, invol.pig instruction, invocations, as well as various other tasks switch features in the CPU. Okay, and then we're going to go through and look through all the invocations of this. crregs, good. So rg this. I just want to see the arguments that we're passing up seem to not always be the same. It looks for writes to CR3 they might be. So we're just going to kind of ignore all of the parameters that are passed up. Task switches, it gives that. So it has some information. Invol.pig, for example, it gives the address. For writes to CR3, it's going to give the value that is being written to for that CR3 value. Yeah, actually, I don't know why. I actually can hear my own voice. Let me try and figure out what's going on here. I don't know if this is a setting. Monitor and output. Monitor off. Test. Okay. That seems to fix it. I had it in monitor mode when I was doing some testing. So that should be better. I don't know if you guys were hearing the echo. It's probably like right overlaid anyways, so you probably weren't hearing it, but I could kind of hear that. Okay, so effectively, I don't know. What I want to do is I want to see if the new CR3 value is going to be updated. I want to see if the new CR3 value will be updated by the time this occurs. So basically, at this point, CR3 has been changed, and read reg, CR3 write, set CR3. So CR3 has been modified by the time we get to this point, so we don't actually have to worry about the passing this information up. So while we do pass this up to Franzia, we can simply ignore it. We're going to grab this is always successful. I don't think this is required anymore. I think we changed the format of these fcalls and not having to set this value. But I can say print tlb change CR3 is now this, and we're technically not looking at CR3. We're going to be looking at the page table. So we're going to look at self.regs.page table, I think is where I put that. The new keyframe should be generated by now. Looks good. We can make our rekeyframe quickly. Cargo run start calc. And we can make this whole process a little bit more seamless, and I've got an idea for that. So obviously we're seeing the CR3 changes, looks great. Some of these aren't CR3 changes, these are probably invol.pig, so when things are getting mapped, like mmap and page table modifications happening internally, saving keyframe calc stepped, that looks fantastic. Now we can turn this back to false, and now we can run, this is gonna basically run the fuzzer. Failed to write in the command buffer. Fuzz with 1. Filter in the command buffer 0. Set rust. Oh, that's because we're on calc and we want to be on calc stepped. Okay, so we can see all these CR3 changes. While it looks like a lot of them are happening, if it's not happening like in the orders of tens of thousands of times per second, it's not happening frequently. So this is happening maybe 200 times a second, probably 100, not a big deal. So what we're going to do is we're going to invalidate the table. So what do we call it? Let's look at the FC coverage implementation. That's going to use query module. Then here we have the module list cache. If we look at module list cache, it's a module list. And we can just clear it by doing that. So that will reset that. So fctlb change. And now we're just going to clear that module list cache. And I think we're done. So now what we can do is we don't have those calc step folders anymore. I think we moved them all. So now what I'm going to do is we're going to do cargo run server. We're going to do this in the Unix one. So we're going to set up this new server, and then we're going to deploy this out, and we're going to see what kind of crashes we get through. So, yep. We want to remove that information, blah, blah, blah. Okay, so that server is up and running. We can now bring our Brawler client online, have them connect in, and start up those fuzz jobs. Hopefully. Actually, yeah, that should be fine. There we go. Okay, so those are coming online. This is telling me the amount of CPU time that is spent for each command in the server. I was doing some performance analysis last night on the server, trying to figure out things that could cause us to kind of speed things up a bit. So now we have calc step crashes, and what we want to see is we want to see that there are really no more help viewer crashes, and we want to see that almost everything is now in calc.exe, and the modules and offsets should be correct now. So anytime CR3 changes, so a context switch, we invalidate that module list, and anytime that the OS potentially modified a page table entry by an OS, if it modifies a page table entry, it has to invulpig. If it does not, the processor itself will cache an old version of the page. So we should be like extra clearing it. We're probably clearing that information more than we need to. Coverage is not getting reported up. I think, let me check something quick. I think I actually disabled that as a quick add input. I was making some changes to Brawler, and I think I probably have a return in here. Report crash, request input, report coverage. That looks good. File length. Let me double check coverage. I know I put like a return in one of these, like an early return. Let me see. Request input, report coverage. So this is going to happen if report, which is, where is that set? Update coverage. If report is true, then the coverage will be reported to the remote server. Okay. So update coverage here. This is, what is this in? So this is when we have connected. We don't want to report coverage when we are downloading coverage information from the server. I see. Yeah, we probably lost this in our... Okay. Yep. Shared lib TKO. We lost this in our merge. We picked the wrong side of a conflict. If I recall on Twitter, you might release Francia by the summer. We're looking at maybe early next year now. we're not trying to sign up for a specific time to release it, because we're waiting for it to be usable to a very high extent. We recognize that if we were to release a tool that had bugs or big warts, like this tool does, if you've been watching me use this for the past few days, we've had to fix bugs pretty frequently as we're using it. I'm making the decision to kind of hold it back. I feel that if we were to make a decision to release it early, there's a chance that people would try to adopt it. It would not work in the way that they want it to work in, and then that would hurt future adoption. Basically, people would brush the tool off as, oh yeah, I tried that when it first came out, it didn't work. So what we want to do is we want to make sure that out of the box, when we release it, that Linux support works, GDB stubs exist, Windows support works on Windows 7 through modern Windows, time travel debugging is working on all of those targets, GDB has full enlightenment such that we can do Linux and OS X and like FreeBSD, all the different operating system time travel debugging. So we're just trying to make sure that everything works perfectly before we get it out there, because if you release something that doesn't work out of the gates, people will be unwilling to go back and try it out after you've fixed the issues that you had. So we're just kind of pushing it back as we find more and more issues. The release date is not official. We'll never make an official release date. Maybe we will like a month out. But we're going to keep pushing that back as we run into things that we think might deter a user from adopting the tool. So that's effectively where we are. So now in update coverage, this gets shared memory. This does all the hashing. I think we can do this. This takes module ID, time, date, stamp, image size, offset, and report true. And let's see if this calls the coverage time event function, and it does. So this function basically replaces everything we're doing in here. So now, basically, if we were able to resolve the module, we'll update coverage with the module ID, time, date, stamp, image size, offset, and we'll report that coverage to the server if we're connected to a server. Otherwise, we'll do nothing. So report the coverage, save the coverage, and optional, and send it to the server if one is connected. Okay. So add input, client mode, takes that. Okay, so that should fix those issues. And let's get that server up and running. See what happens. We should see some good crashes coming in, and coverage numbers should hopefully increase this time, and we should also see inputs getting saved associated with that coverage. So we saw coverage, we saw an input, coverage is growing, looks good, like to see that. Fuzz cases per second look reasonable. All the workers are online. So basically, some of these operations, this is like sending up pages, and this is syncing coverage. So the coverage sync right now, I added that page cache yesterday, but I also need to have a better cache on deduplicating coverage reporting, such that all of the threads don't end up re-downloading coverage. That's honestly actually not too hard of a problem. I could probably add that in 5 minutes. I know of a good place that I could add that. So we're getting all the crashes. Coverage looks healthy. Everything looks good. The crashes come in really fast. We already got a DCPL violation. So this is basically writing to a completely invalid address. If we take a look at this, this is So we could look at where that crash is. I can't remember. Oh, it's probably this. It's the 30, 30, 30, 30. So the all zeros here. So this is a crash that we're going to want to look into. That one looks really interesting. That looks like an ASCII deref, and this is the one that we're probably going to look into maybe getting control of. So we're going to let this run. Everything looks good. I'm going to make a commit here, git status, git commit am added page table and invulpig awareness for module listings. Git push. Sweet. Okay, and everything looks good here. So what I'm going to do is I'm going to go into a brief intermission. It is 6 p.m. right now. I have not eaten food yet today, so I'm going to just quickly get some rice prepared in my rice maker, and I'm going to start unthawing some meat. So I'm going to make some dinner. But I'll be gone for a couple minutes here, probably just like 5 minutes to set up this rice. Thank you, Grimanja, for following. Rocket Duke, thank you for following. So I'm going to do this fancy transition now, and we're going to go into a quick intermission. And let me get some music for you, too. Lo-fi hip-hop. All right, see you guys in a bit. I see the enjoy your food. Thanks for the stream. The stream is not over. We're going to come back and we're going to start looking at these crashes once I get this food up and running.
It only does it about once a week. But why does it come down to the ground to do it?
And why does it nearly always choose to do so in exactly the same place? Whatever the reason, it must be very important, for a sloth on the ground is almost helpless.
Any predator could attack it, and it doesn't have the speed to escape. Why it comes down in this way is a mystery.
All right, we are back. Got rice in the rice cooker. I've got some meat unthawing. Gonna have a good meal tonight. So, let's take a look. Let's see if everything looks good in crashes. Let me switch away from intermission. Oh my god, that's so weird that I'm like doing a real stream thing. Okay. So everything looks good here. I don't see any of the help pane crashes anymore, which is a really good sign that we're that the fix that we made. We spent 2 hours on like a 5-line fix, but we did it correctly and we kind of explained how it works. So I hope you guys enjoyed that. But now we're gonna hop in kind of to the meat of the stream. We're gonna start looking into reproducing some of these bugs. We're gonna work on classifying some of these bugs to see what they look like. And then we're going to try to find a bug that maybe we could get control of. And there are a couple candidates for that, so we're gonna start poking around. So first I'm gonna filter this by .crash. So this is showing that we have 16 unique crashes. And in this case, a unique crash is classified as the location that it occurred in, so the module and offset, and the type of exception that occurred, as well as whether or not it was a read or write or user or kernel deref or a null deref. So null derefs, I treat null derefs, anything as null deref if it's within, I think, like 1 meg of 0. So if it's negative 1 meg address, so like a bunch of Fs, all the way through 1 meg, I treat that as a null deref. If it's between 1 meg and the boundary between userland and kernel land, I consider it a userland deref. And then if it's in the kernel space, I just assume it's a kernel space deref. And that kind of allows us to reduce the noise. So for example, some of these crashes will likely be, we can look at .regs. Some of these crashes are probably going to be kind of arbitrary, where the contents of what they're accessing could change from run to run. So in this case, it's accessing this one OD. I think we've seen that before. This one is accessing a 52058. That looks like ASCII to me. So basically, when I see text, when I see ASCII, I assume that this is likely a controllable address, so these are high priority. Almost anything that says null, I'm just immediately discarding in my head. I'm just thinking, not really relevant. Here's a write to a null in, so this is a write of -1, which I consider a null deref in NTDLL. We have a read of null. We've got a crash here. This one's really interesting. This one's derefing all UTF-16 zeros. So this is 4 zeros. Maybe that's calculator text entry. So this one's pretty high up on the list of something to look at. And then these are unrelated These are 6s. If I'm not mistaken, that is undefined instructions being hit in these different kernel things. So we can actually go through and take a look at what a crash, one of these kernel crashes looks like, because it's just fun. We can do whatever we want here. So I'm gonna make a copy of the calc.exe file. And the reason I want to make a copy is so we don't clobber the coverage information that we have. So everything's named based on the keyframe that you're using. And if I were to do a repro on calc.exe, it would end up clobbering the coverage file that's actively being generated by the server. I don't know a great way to change kind of that usability aspect of the tool. It's on my mind of something to change. So cargo run repro. And we're going to repro a calc.exe copy. That is the name of the keyframe. And then we're going to give it a path to a crash. So in this case, we can say calc.exe crashes. And we'll whack in... Which one do you guys want to look at first? Let's look at one of these kernel ones, quick. This is not necessarily an actual bug. This is likely the kernel is trying to use an instruction and then it's in a try catch. So if this were an actual kernel blue screen, we would see a blue screen crash, which is a separate kind of style. KDNet connection 127.0.0.1.3.3.3.3. So that's going to connect to our KD server. So here we're going to set up a KD server. This is going to connect into it and reproduce that crash in this KD server. And of course, could not find the file specified. This needs to just be a .crash file. So now we've broken in. We're gonna let this resume. We're gonna see where this invalid opcode is happening in the kernel, just because it's interesting. Hello, F Mega. Welcome to the stream. Thank you for following. Okay. This one's deep. This one runs for a while. And here we go. We hit a UD2. And that is exactly an undefined instruction. It's put in there by the processor. It's really cool that we can go in and reproduce any bug that we see. So if we do a reload, we can try and see where we are. Here we're in something, I guess, I don't know why there's a UD2 here explicitly. Usually that's put in as like an assert or some other issue. So what's likely happening is that whatever is going on in this SPSys just issues a UD2 for whatever reason. I don't actually even know what SPSys is. So, and it doesn't look like we have symbols for it. SPSys we don't have symbols for, so maybe this isn't something to be poking around in. I have no idea. Okay. So we got a couple crashes here that kind of stand out to me as interesting. This one is exceptionally interesting because this indicates that 30s are being derefed. So we're gonna go through and reproduce that crash quick. Ah, fuck, I shut down the server. It's not a big deal. I knew I was going to Control-C the wrong window at some point. But luckily, this should go, and all the coverage is saved, so it reloaded the coverage. All the inputs were saved. So these servers will actually come back online, and they'll be resumed from where they left off. So we actually didn't really lose anything when that happened. It's going to take a little longer for these to start up now because they have to sync their databases. And there's some improvements I want to make in that protocol soon. But this is the one we want. I'm going to actually minimize this to make sure we don't do that again. Okay. So, actually, let me double check that those workers are connecting in. They are. They're all syncing and they're running. So all of them are up and running. They're getting code coverage. All of that information that they had, they're up to date with the server, which is really cool. This server stuff I wrote like a week or two ago, and it is awesome. I gotta say, it is awesome. So we're gonna minimize that as well. So here we're gonna set another KD server. We're gonna grab the name of this crash. I think it's still my clipboard. It is. We don't want the regs file. In fact, I'm gonna change this to star.crash. Okay. All right. So this is broken in. We're gonna reproduce this bug. We're gonna see what it looks like. This is by far the most interesting bug out of the batch. And what we're gonna try to do is, we'll get these symbols. We can see that we're dereffing 30, 30, 30, 30. And if we look above at where this came from, at rax plus 18, we can see that it's just a bunch of zeros. And when I see a bunch of zeros, this makes me wonder, what could this be? If it's zeros, that makes me think, I don't know, what, in a calculator application, what would be a lot of UTF-16 zeros? And something about this makes me think it's an input or something we might actually control. So I'm not quite sure what that is. So what we can try to do is let's see if we can figure out who writes the zeros to this address. Do I have break on access? I don't know. I don't know if we support break on access in our KDNet implementation. Let me see, BAW4. So we want to see who writes to this address. And we can use a hard-coded address because it's deterministic. We know that every single time it will be the exact same address. Serialized K special. Yeah, it looks like we don't have break on access support for that. That's a little bit annoying. I'm trying to think how hard that would be to add. An access breakpoint. It's relatively hard because that's going to be in a CPU register. Not quite sure. What could we do here? Let's see if we can, let's get this loading up the, our repro, or our KDNet driver, or a KDNet extension. So we'll go into dev TKO fuzz, Franzia, windbag plugin, and we'll have this load up this keyframe.dll, and maybe we're gonna go and get the keyframe time travel stuff working. We could potentially have it automatically take a keyframe every like X amount of instructions, and this would allow us to go forward and backward in time. So if I go to keyframes, if I go to keyframe calc stepped, this will jump back hopefully to the start. Hit end it. Yeah. I actually might need to get rid of that. That's actually an issue because that doesn't allow me to jump backwards in time. Interesting. Okay. So we could either try and get time travel debugging to be really fancy, such that we can kind of jump back and forwards. Or we could maybe just start looking into the bug. We could look at trying to fuzz around this bug to see the different variants of this crash. So reload K, heap, actually U rip, K, UB rip. So the bad address that we're getting is coming from RAX. So let's see if we have heap information on that, and it doesn't look like we do. Likely we don't have the right heap metadata in use. We're not using a debug build, and we also might not send that the correct information over KDNet. So the KDNet implementation, we basically had to kind of reverse out. So there are certain functionalities that we're missing. We have all the core functionalities like breakpoints and jumping forwards and backwards in time and stepping. But we definitely struggle with some of these weird, obscure extensions that sometimes use features that we don't know exist. So I could maybe have it write out the entire instruction trace. Basically, I want to figure out... So this bug we know is probably an uninitialized memory usage. And this uninitialized memory usage is basically causing 30s to get derefed. And we don't necessarily know what's going to happen with those 30s. Let's actually take a quick look in IDA and see what this code approximately looks like. And I'm going to grab the coverage file from Franzia. Actually, I want to leave this search query open. Oops. Calc crashes star.crash. We're basically going to refresh this every once in a while to see if new crashes come in. There are a couple that I'm looking for to come in here. There was a write in NTDLL that we had yesterday. We could potentially put that in the input corpus, and that would give it a chance of that going through, or we could reload the inputs from the previous run overnight to try and repro those. But I want to see if they organically get found again. And we'll go into, we'll grab the calc.step.coverage.text, paste that on the desktop, and we're going to use Lighthouse to load that code coverage file, and that's going to color IDA with all of the coverage that we've seen so far. So at this point, we now can see everything that has been hit in the fuzzer, and this allows us to notice if there's anything we're missing. I can sort by complexity. We can see like these, this is a complex function. If we look at our coverage of this function, it says 23% covered, but it says 365 out of 455 blocks hit. I'm guessing this instructions hit count is not necessarily accurate. Let me see if, I wonder if there's a way that I can change that. If there's some options. Plugins. Not quite. So basically we're gonna kind of have to ignore the coverage percent. We could try it and quickly make a modification to Lighthouse to have it give the coverage percent as a function of blocks rather than instructions, because obviously blocks hit here shows that we've hit a lot of the blocks, and instructions hit is just, there's no way this is accurate. There's no way that the average block is 2 instructions. So something is a little bit off here. So if we look, we have pretty incredible coverage in here. So if this is process command worker, I don't necessarily know what this is doing, but like, so far in this function, we have hit every block. Here we have some blocks we haven't hit. It doesn't look too big. What I'm basically doing is I'm like zooming out, and I'm trying to find blocks, like massive blocks that aren't hit. So zoomed out, I can see due to kind of the color, what has been hit. So all these blocks have been hit. All these blocks have been hit. So we've got 3 blocks that haven't been hit there. But everything has been hit up at the start except for 3 blocks, which is pretty incredible, to be honest. We can come through in here. We've got some history stuff. We've got a loop in there. So I'm just kind of scrolling around to see big blocks that we haven't hit. And honestly, we have pretty incredible coverage of this function. And this is the most complex function in the calculator app, and we are covering almost everything. We've got a couple cases here we're not hitting, case here we're not hitting. We've got a destroy and create here that we're not hitting. create num we're not hitting here with a mem copy and a local free, so that is heap activity. Here's another mem copy in here that we're not hitting. A local free here. This is a enclose. So we don't necessarily hit this block, but we do hit this function. Couple destroys, couple cases here. So I'm curious if this is like maybe allocation failures. Let's we can maybe see why those are happening. A couple of these, they all seem to have the same shape, this create num mem copy. So we could maybe learn what's causing these to occur. Some local freeze down here, more local freeze here. Create enum, create num. Down here we have another enclose precision inversion brackets maybe. Okay. Convert to number objects. So this is something, we are hitting this function, local freeze. I'm guessing this is maybe a ref count. Compare this to RSI. There seem to be a lot of situations where you can free things, and I'm curious what those are. We can try and learn what that is, and maybe that can be added to our fuzzer. But other than that, the coverage in this function is pretty impeccable. Handle error command. We are hitting this. This is doing a VF table call, so it's possible we're missing a VF table that we've never hit here. In this case, this in RBX. We're maybe never invoking stuff on that. Some loops in here. This is, I think this is a divide by 10. This with the shift. We just can Google this constant. Division with the remainder. I think this is a div mod by 10. Potentially magic numbers. This, yep, divide by 10. So if we want to divide by EAX by 10, and this is doing this with the 3, so this is doing a divide by 10 in a quick way. So if you're not familiar, divides on a processor cost about 40 cycles, multiplies cost about 2 to 8 cycles. So by doing this operation, you can perform a divide much faster. This is basically multiplying by a reciprocal. It's kind of how that works. So, oops, I want graph view. Switch back to graph view. Okay, so that function looked pretty well hit. Obviously, there are a couple blocks here and there. There seemed to be a pattern we were missing. Win main, I don't expect that we'd hit much in win main. We're probably going to hit the message processing loop. I bet if we find where we have colored blocks, we'll probably find it's a tight loop. And if we look, it's translate accelerator. This is basically handling all of the messages that come in. It dispatches those, translate, dispatch message, get message. So this is like the get message loop. We don't really have a way to break out of this loop unless we were to somehow kill the calculator. We need to add that as a way. We need to add exiting to our fuzzer, so I'm going to make a quick note of that. Oops. One second, my mechanical pencil is fighting me here. Where's the lead at? Come on, there it is. Looks good. Okay, so we need the fuzzer. Should break message loop. That would just get us a couple states, and exiting an application typically is where teardown and destructors get invoked, and that can be a place to find a lot of interesting potential use after freeze and uninitialized memory uses. What else do we have? Yeah, so like that would go through and unregister and call all these destructors, and that's something we want to see pretty badly. What's up here? Get file version info. I just want to see if there's another message loop or anything. I'm guessing this is calc loading up. Get process heap. Close service handle. SC manager. Query license value. Set foreground. So that's all startup stuff that we're probably not going to be able to hit. That coverage doesn't really matter to us as we don't have control of anything as an external application until these things have happened. Obviously, there are some DLLs and stuff that we could overwrite and get execution in, but our goal is to get code execution in calculator only with like mouse keyboard inputs. So we got some printfs. I'm guessing this is parsing some configuration files of the system. So nothing too crazy here. Load library, create thread. I don't know why it's creating a thread. Let's see what it's making. Non-genuine dialogue worker. Okay. So we've got a guest message loop here. So what happened is it got the first message. So this is just like a do while loop effectively. So we get message and then we handle the message, and then at the end we'll get another message. So we are in the core message handling loop. Let's see, translate accelerator message, global tagging, handle when main message. That's probably where everything's happening. Okay, let's take a look into this function, see what we're hitting. Compare with 100 if it's... Okay, so we might be missing almost everything in here. So there are certain messages that we're missing. Here's a get key state. Check window class. So this is where it probably handles key presses. If we look in here, let's see if there's any functions we're missing. Get dialog item, send message. It looks like everything is actually done through the commands. If we look at... this is sending a 147 message. Let's take a look at what this is doing. We can take a look at OX147 send message. So that's going to be is that control get? CB get cursor selection. So that's going to get where the cursor is on a drop-down box. So this is basically probably looking at a drop-down. It's getting what's currently highlighted. And then it's going to get the results of that to determine some different things to do. It's getting some parents. But it ultimately doesn't look like we're really missing too much in this function. Unless one of these explodes. Get node. Check window class. That's going to exit if the check window class fails. We're hitting every single block in this function. Fantastic. Okay. Oh, I can already smell that rice cooking. It smells really good. Okay. I just got a fancy rice cooker, which is making my life so much... Like, I've never had rice so good at home. It's... I don't even know how to describe it. It, like, makes no sense. So here we have number get. And I'm not quite sure how we're actually getting blocks hit in this function. Like, I don't know what we're possibly hitting in this function. And it doesn't look like we're hitting anything. Didn't this say... Oh, we're hitting nothing in here. So this is a really complex function. We're sorting by complexity. And this is a really complex function that we're never hitting. And there's a chance that this makes no sense. So we're actually going to go into proximity viewer here. We're going to see numget hit by a lot of iterators. This might just be template generated code. We're hitting a lot of stuff under it. Yeah, this looks like it's in the weeds of templating. So I think we're just going to assume that right now this code is not reachable. We've got an arithmetic evaluator. So this is likely like the calculator. This probably takes in an expression or something, or some pointers to things to do, and this will evaluate it. This is probably the core functionality of the calculation processing stuff. So we got calc engine, display history, process command. What's our coverage like? We're missing an unwind, so we're missing an exception handler here. Everything looks pretty good here. We've got a couple things we're missing. Comparing with V, comparing with R. I don't know if these are all the keys that are pressable. Let's see where it's getting this from. So EDI is interesting to us. We're just going to trace through where that came from. EDI is there. That's LEAing. So this is going to do a transform on RDI. Not in place, though. Here we're doing a compare. Keep going up. Compare LEA. That's just an argument. So what we could do is we could open a debugger and we could try to see what RDI is at this location. So let's put a breakpoint on this function. So we're going to open up a calculator instance. Open up WinBag. We're going to attach to that calc instance. And we're going to put a breakpoint on this function, bc star x. We're going to search for all symbols in 132 calc containing fevaluate. And it's this. Just needed to do the conversion between ida and not. So if I hit a key, that does not show up. Okay. Equals. Multiply 5 equals. Surprisingly not getting hit. Arithmetic evaluator. 5 minus. I'm so used to RPN that I don't even know how to use a non-RPN calculator anymore. What would cause that function to get hit? We did set that breakpoint. I would expect this to get hit in so many cases. 5 times 5. Huh. I'm just trying to click random buttons to see if we can hit that. I'm really surprised that that is what I would assume to be core functionality. And we're not hitting it. Fevaluate. There. Okay. So this is hit and do unit conversion. I mean, we actually could have just xref'd this, and that would have pretty quickly showed us when that could occur. We're going to make this a little bit bigger. So we're going to go back into this function. Oops, we don't want that. Back into the arithmetic evaluator. And then we're going to look at xrefs. And we can see that the calculator controller does it. Compute unknown argument, and do unit conversion hits it. So do unit conversion, we're actually not hitting anything in. So that means we've never popped up the unit conversion dialog and typed something in the text box. And that's likely because without key presses, it is impossible for us to type into that edit box. So what we're probably going to need to do is add that. So I'm going to say we need fuzzer needs key presses. Fuzzer needs key presses. And then we need to specifically make sure that they can get key press to unit conversion. Because without those key presses going to the unit converter, we're never hitting this function at all. And this function is relatively complex, so we're potentially missing out on a lot. We've got subfunctions in here. Let's see if those are getting hit. Create timed calc. Fork. We got module handle. There seems to be a decent amount of stuff. I'm trying to figure out approximately the state space that's reachable. We've got a destructor here. I'm guessing this is ref counted. I want to hit some of these frees. We need to figure out how to hit some of these frees, because if we're not hitting those frees, we're gonna have issues. Failed to get expression from that, from template manager. Set window text, load string, send message, imp free. We've got some frees here. Yeah, there's just definitely a lot of stuff we're missing here. Let me grab that coverage file again and we'll see if anything new has maybe shown up. So we'll grab coverage text, paste it on the desktop, then we'll reload that coverage file. Yep, we still have not gotten any coverage in this location. Process keypad inputs. This one we want to hit like almost everything on. And it looks like we are. We're not hitting this case, which calls delete current item. We're never hitting delete current item. That's a big issue. So let's, that one we're going to want to bookmark. I didn't mean to do a breakpoint, but you know what? That's actually a good way to bookmark in a kludgy way. So basically, we want to hit this function. We're not. We can play around with the actual calculator app to figure out where we could hit that. Is window enabled? Dialog item. Send message. In this case, we're not hitting. Enum child windows. In the case of 41D. So we're never, I'm guessing a 41D is something that is not in our list. I bet if we were to add a 41D to our generator of parameters, we would start hitting that block. Basically, we never have a way of generating that. Sign inversion, add keypad input. Okay. So that function looks pretty solid. Load formulas. We never hit this function at all. Well, that's probably loading stuff that we will never be able to hit. Let's, we can double check xrefs and see if it looks like we should be able to hit that. Statistics tool is in the VF table for the stats tool. I don't think we're going to be able to hit that one. No problem. Stream get read constants. This function's gross. -1 pi. Okay, so this is just like you give it an index and it's like gonna go through all those. Okay. Scicalc functions. So there are a couple things we're not hitting. We're not hitting the exception handlers. Oops. Layout graph. Yes. So it looks like we're hitting everything in here except for try except blocks, which is fine. So that coverage looks really good. Send characters to display control. Once again, we're hitting almost everything here. We're not hitting this one is X digit. So this is probably some mode. If you take a look at this, is there anything that sets it? Change mode. In change mode, this sets it. So I'm guessing somehow we're maybe never getting into this mode. 0, 1, 2, this might be the programmer mode. So somehow we're never getting a send character to display control while in programmer mode. We're hitting is digit. So basically I see is X digit, and the only place where it would be handling hexadecimal digits would be the programmer mode. This happens to line up with the zero indexed option. So if we were to look at calc, we'll find that the calculator, the 0, 1, 2, that's the programmer mode. So that's kind of where the 2 is coming from in my head. So we're not hitting this because we're probably never typing a hexadecimal digit in that mode. That might be because we're never activating a radio dial or the radio button, so we might never be putting it into hex mode. So what we could maybe try to do is see what happens when we go into hex mode. So we could probably just search for strings here and make a lot of progress. We're going to search for hex in the strings window. Really? I guess that must be in our resources file, or we want Unicode strings as well, and I bet we're gonna get it now. Hex. No, we're not. Okay, so we'll just look for functions. Really? Maybe a just normal name. hex. Nope. Okay. So X digit, we can look for that. Is X digit, we can see who uses this. Send characters to display control. Wow. It's the only place that uses that as well. Is number valid? Put num. Settings changed. It's a good function here. Display num. Okay, so we definitely want to add keyboard input support. We probably want to have some like tab support such that we can maybe switch through some of these dialog fields. Oh, my rice is done. Okay, interesting. So I think we've learned a little bit about what we're missing. It seems like key presses would make us get a little bit of progress. Programmer mode, let's take a look at programmer mode. We're definitely hitting programmer mode. This dialog item we're not hitting, maybe. What else? This is probably another dialog item we're not hitting. So I think what we want to do is we want a random chance of creating a dialog number that we don't know exists. Notify, prepaint. Yeah, so we're never setting this radio button. The only radio buttons in this mode are those. So it's possible we're missing some of those radio button IDs. And cool. So I'm going to take another quick break. I'm going to start getting the meat on a stove to start cooking the beef. And then I'll be right back. They'll take probably 2 or 3 minutes. And we'll be back and we'll look at basically what we need to hit these things. We're going to confirm that key presses will hit this code that we're missing. And then once we've confirmed that, we're going to go and start implementing those things inside of the fuzzer. So I'll be right back. got some food on the stove. I'm gonna need to take breaks every about 3 or 4 minutes, just like quick go over there, stir the pan. I'm just gonna set up a little timer here to remind me, otherwise I will forget. Okay. Sweet. So what we have here is we've kind of determined that we're missing a little bit of code coverage in calculator, mainly due to key presses. We've found is one big thing that is causing us to miss stuff. We also found that there are certain dialog buttons that we're not hitting, so we want to add some noise into generating some of those. So basically right now we only generate streams with known dialogues, but we're never going to find a new dialogue item because we have no way of generating a number that might be a different one. So that's a relatively easy change. Okay. One worker on, oh, that's the repro. So we've got 64 workers online, getting good fuzz cases. We're getting about 2 a second. And let's take a quick look at crashes. Think we got more? Yes, we did. So we have a read from user here, which is kind of interesting. We can take a quick look at what that is. Looks like an interesting crash. Actually, we have, this is really interesting to me. And that one just came in. This is the most recent one that came in. So if we look at recency, this one came in about 18 minutes ago. We got this crash. So we're going to repro this quick, see what it looks like. Okay. How's everyone's evenings going so far? Where's everyone from? Okay. We'll reload symbols. We'll take a look where we are. We are dereffing. We're in free. We're in RTL free heap. We're working with an address that's clearly bunk. We've probably ended up with some sort of an issue here. And this is probably the same bug that we've seen. Actually, this is in release categories and tool definitions. I don't know if we have seen this bug before. This looks like probably a use after free. Whenever I see a crash in a free function, I just assume it's usually use after free. Could be a double free. Could also be a heap corruption. Heap corruption could be like a a buffer overflow in a heap allocation, causing metadata to get corrupted. And then here we're processing the metadata in that free function. In this case, not sure what it is, but this is very high priority. This is a really interesting crash here. So then we're going to take a look at this one, which looks even more interesting. Whenever I see the OD, that is a general protection fault, and that basically means that you accessed a non-canonical address. So on x86, a canonical address has to have the top 12 bits of the virtual address set. Technically, it varies by the processor and you dynamically detect it, but for all intents and purposes, that's why you see, so the maximum user address on an x86 processor will be 1 shift left 48, or actually, so an x86 virtual address, the 48th bit has to be, the 47th bit has to be sign extended. So this, for example, is not a valid x86 address because the 47th bit is set, but the others are not. Basically, all of these bits need to be set to 1 if this bit is 1, and all of these bits need to be set to 0 if this bit is 0. And that, so if we go and make 1 left shift 47 minus 1, this address here, this is the highest user address that is possible in x86. And then the next virtual address that is valid after this is not it is not equal to this plus 1, because this is not a valid address. The next valid address is this with all of these bits set. So this is the next address allowed in memory. So this is why you see kernel addresses in this higher half. They're in the higher half of canonical address space, and the others are in the lower half of canonical address space. Now the processor, when it's executing, when you access invalid memory, typically you get a page fault. It's basically a page table walk occurred. It failed to find a valid entry, or the permissions are incorrect for the operation that's being performed. And what happens there is you get a page fault exception. However, if the address is not canonical, basically if it's not in the correct form where this bit is sign extended into the 12 above it, you actually get a general protection fault. And the general protection fault is this OXOD. This is the exception code for a general protection fault. So typically, that means when you see a crash that's a general protection fault, it's because the address is so invalid that, sorry, got my timer. Basically, it means that the address is usually so invalid during an access, and that's usually a sign that it's been completely corrupted. So when you see a page fault in user, this is the address that this is accessing is likely an address that maybe was valid and has been freed, or maybe it's slightly out of bounds of a good address. But when you see a general protection fault, that usually means that something that is not a pointer at all, or was never a pointer, maybe a string or some ASCII or something usually controlled, has been derefed. So we can take a look at what's happening. Here we see that we have a write into this address, which is completely broken. Yeah, this is likely an exploitable bug. We would need the right grooming primitives to get control of this memory, but what this is saying is that we're able to write to an arbitrary address. Obviously, we're hitting a crash that is writing to an address that is completely invalid. So this bug is going to be very high on our priority. And basically, based on just seeing this OXOD, I knew that this was going to be interesting. And that's why I format these file names in this way. It gives a lot of glance value into kind of the state of these crashes. We're also going to want to look at this write null. Even though it's a write to a null address, it still might be interesting because it might be writing a null pointer coincidentally. Got a couple new people. We got Zaponer. Thank you for following. I'm gonna make one quick break to stir some food. I'll be back in like literally 10 seconds. All right. Can you show where it indicates a general protection fault? Yes, that is this OXOD. So the PF shows that it is a page fault, and the OXOD shows that it is a general protection fault. And I could actually stringify that and add that as a nice feature to TKO. So if we want to really figure out where that comes from, we can take a look at the Intel manual. So I'm just showing you like how I find the Intel manual usually. Just Google it. Click on software developer manuals. In this case, we are interested in the system programming manual. And if we look at this, download it, blah, 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 we can find that there's going to be a section on exceptions. Under here, there's going to be a list of exceptions, exception and interrupt reference. And we can look, the 13 is a general protection exception. And if we convert 13 decimal, it's hexadecimal D. So that's how I know it's a general protection fault. So I've basically just memorized almost all of these over time. You just get kind of used to using them a lot, but this is where you find these if you're ever interested in that. You can also search for like OSDev Wiki, IVT. I do this because I wrote this. I made this like little table. It's nothing fancy. It's just I change some information around, but like you have your div by 0, a reserved one, NMI, breakpoints, overflow, bound range exceeded, invalid opcode, which we saw invalid opcodes in our in here. So these are invalid opcodes, and we went through and we verified that indeed they're running an invalid opcode. But yeah, that's roughly kind of the process for that. How do you determine when something is a null write? So I classify a null write as something plus or minus 1 meg from 0. Maybe it's slightly less. Maybe I do 32K from 0, but whatever it is, it's just a certain distance away from 0. That means something that's dereffing all Fs will also show up as a null deref, as typically that's what it is. So, okay. So that looks pretty cool. Now I actually have to take a slightly longer break because my meat is done cooking. I have to make the marinade for it. I'm making bulgogi. I'm actually making bulgogi elk, like a spicy bulgogi elk with some white rice. So I'm going to make this might take me, let's say 10 minutes at most. So I'll be right back. Feel free to ask questions in chat or do whatever, and I will try to respond to them when I get back. So see you very shortly. All right. Got my food finally ready. It looks and smells amazing. Last time I made this, I didn't make it spicy enough. This time I made it a little bit more spicy. Well, hopefully it's not too spicy. But while I eat this, I'm gonna turn the microphone off. What's up, Rembound? Rembound? Thank you for following. So I'm gonna turn the mic off a little bit while I eat, and then let's see. I'm trying to think of something I can do without talking. We can just look around kind of some of the coverage. Maybe we can poke through some of the crashes. So I'm gonna do that a little bit while the microphone's off. I'm gonna leave it on the intermission screen. I'll go to this one. But yeah. Wow. I don't mean to brag, but I think that is the best meal I have ever cooked at home. I made bulgogi elk, just over white rice, and I've been working on my bulgogi for about a month now. I've been making it like 3 or 4 times a week. And the last time I made it might have been the worst bulgogi I've made out of the bunch. But I finally have found the right balance of spice, like amount of pepper, and the type of pepper. That was phenomenal. I can't wait to be hungry again to eat the leftovers. That was unreal. Navy Sneal, thank you for following. The Droid Geek, thank you for following. And Nitron48, thank you for following. I'm glad everyone can be here. So, while I was eating, I kind of made a couple modifications to the fuzzer. I don't think it will have a tremendous impact on the results, but we noticed that when we were looking at IDA, when we were looking at kind of the coverage that we had some issues with some command IDs not getting hit, or what looked to be command IDs not getting hit, that were within the ballpark of the commands that we know and love. So what we've done is we've slightly skewed these. So we've switched from randomly corrupting one to replace it with a known ID to having a 50% chance that we'll pick a random command in our command stream, and then we'll either skew it forward, so we'll add up to 16 to it, or we'll skew it backwards, so we'll subtract up to 16 from it. So that will kind of fuzz nearby the known IDs. They do seem to follow kind of the pattern. It does look like those IDs were made by a human, such that someone defined kind of their interface layout. So I think the 16 plus or minus will probably get everything. I would have done a higher random number if I thought that was a potential issue. And then I have a chance of flipping a random bit in here as well. What is the approximate fuzzing speed? The approximate fuzzing speed is about 1.6 fuzz cases per second, which is really not too bad given we're fuzzing a GUI application that we're like jamming inputs into. And these fuzz cases, we have a 60-second timeout on. So we're trying to let these run and get into the weirdest state possible. Where did you get the elk from? I have a local market that has elk in stock. It's actually elk from nearby here. It's frozen. But I just like throw it in the sink with some water because it's like in a vacuum sealed frozen thing. I let it thaw out in the sink for a couple, like 30 minutes, 45 minutes, and I just browned it up and I made like the bulgogi sauce for it. I don't know. It's the first time I've had the elk from there. I actually have another pound of it in my freezer. I'm definitely buying that again. It was fantastic. The texture was really good. It wasn't too greasy. It wasn't too lean. I actually had some meat the other day when I made bulgogi that was way too lean, so it ended up cooking way too hard. This was perfect. Loved it. So we got here, looks like we got a new crash. It's hard to say whether that is due to the new mutation strategy that we added, or if it's just coincidence. So that's kind of hard to say. It doesn't really matter. We're consistently kind of getting new crashes. Crashes are almost always logarithmic in terms of you get all your crashes up front, right? In the first 3 minutes, we got more than half of our crashes. Then afterwards, we get the rest. Never had bulgogi before. Weird question. Do you have the recipe for it? Yeah, so I do. I brown up a pound of beef or meat or whatever you want to use. Just a pound of anything will probably do the trick. I use a 1/4 cup of brown sugar packed. I use a 1/4 cup of soy sauce. I put in 1 teaspoon of oil, and I say oil because that is kind of up to you. Most bulgogi beef will use like a sesame oil. I do have sesame oil, but I'm not a huge fan of it. I don't like the kind of nutty flavor from sesame oil. So instead, I use 1 teaspoon of olive oil. And then I add some garlic in there. So 3 cloves of garlic, 4 cloves of garlic. I actually used garlic powder today because I didn't have any garlic, but it still tasted fantastic. I put a little bit of pepper in there, just like ground black pepper. And then I put in about half of a jalapeno pepper, a half of like a medium-sized jalapeno pepper in there. And that really gives a really good flavor that I like. So it might not be true to like bulgogi, I'm not sure. But it's in that ballpark, it's in that realm. So I'm comfortable calling it bulgogi. Sometimes they'll just add different variants to there. Sometimes they'll add some veggies that I'll chop up in there. But mainly it's just the soy sauce, the brown sugar, and then a little bit of whatever oil you want. And then the rest of the spices, the garlic, the pepper, any spice that you want in there. Just kind of play around with it. I've been trying to cook a little bit more from memory, more from like experience, if that makes sense. So I've been trying to add twists to things and then see if I like or don't like it. Often I don't like it, but when I do find something I like the bulgogi I made today, I'm probably going to use that as the basis for all of my future bulgogis. So yeah, it's really simple. It takes, I mean, you can make the marinade while the beef is browning, so the whole meal basically takes as long as it takes to brown beef. Because once it's done, you just throw the marinade in, you're ready. You can let it simmer for a while if you want to get like a better flavor out of it, to let some of that marinade get into the meat. And then rice, I just put white rice in a rice cooker and let that go. And the rice cooker keeps the rice warm, so I don't even have to time it properly. Even if I miss it by 2 hours, the rice will still taste fantastic. So that's what I do. It's really weird. I went from... I moved into a new house like 6 months ago, and I live kind of further out. I actually live in the mountains now. And for the past like 4 or 5 years, I Grubhubbed or ate out for basically every single meal. And in the past 4 or 5 months, beyond maybe a couple times a month going out to eat with coworkers or having fun, I've been cooking everything at home, and oh my god, I'm loving it. Like, I'm just taking the things that I've liked out in the world, and I'm just putting spins on them that I think I would appreciate. You know, like I make burritos a lot, and I know the ratios I like in a burrito. I know how many beans I like versus the rice versus the cheese versus the meat, and I mean the answer is I like a lot of cheese. So I don't know. I found that cooking at home has led to me making better dishes than anything I can find outside. Not because they're objectively better, but for my personal taste, they're better. So that's my little cooking rant. I'm loving it out here. I love living in the mountains. I have gigabit internet in the mountains, so there's really nothing more I need. All right. So we just got another crash that came in. Looks good. We've got, that's in NTDLL. So we can kind of take this stream a couple different ways. We could look at all of these crash files. We could see how all of them look, and we could try and determine roughly where the faulting points are in the location, or in the, we could try and figure out like the call stacks of all of these and look at approximately where these mistakes are being made, and maybe we could write a fuzzer that stresses them a little bit more specifically. We could go down more of a reverse engineering route where we could try and figure out why this crash occurs, and we could try and write a minimized proof of concept for it, where we're going to try and find explicitly a certain bug that we want to. That would be more in line with the direction of trying to get control. We could add mouse and keyboard inputs to the fuzzer, and we could also add a close condition. That would probably increase our coverage by 5 to 10%, which is kind of unlikely that I think that would yield something. I do know of one more crash on the exit of calc, so if we did have a close message added to the stream, added to the command stream, we would probably be able to find one other general protection fault. But all right, let's do the flashy thing. Let's grab some of these crashes and let's see if we can reproduce these on a live machine, and then we're going to start switching over to making a fuzzer that's designed to basically basically try and find grooms and different things. So I've got a tool that I can introduce today called Bride and Groom. It's a tool that I use to monitor for heap allocations. So we're going to grab these two crashes. We're fuzzing calc.exe in Windows 7. Technically here we have Win32 calc. I don't know how comparable they are. I'm going to take a big ol' risk, and I'm going to say that it's likely that the IDs have not changed and that we can use these same inputs and maybe reproduce the bug. So we're going to hop over into, we're going to probably fork the tool that we use for injection. So if we go into our Twitch Fuzz calc, we've got our inject ID sequence project, and I'm going to make a copy of that, and this is going to be inject ID live repro. And then this, instead of doing the weird stuff where it's going to take an input from kind of that weird Franzia calling convention, instead of trying to get an input through this CPU ID that we do here, instead we're going to switch to just loading up that command file. So what we're going to do is we're going to attach to an active calculator session. All we need to do is load that command stream, and here we can print going to send commands, and then we'll just do commands.len, and commands is just going to be a vector. So we're going to load up we'll take in an argument here. Let args is equal to a vector of strings. It's going to come from standard env args. Get arguments to the application. And then we're going to do if args.len is not equal to 2, print usage cargo run repro command stream. That'll do the trick. Return OK. Looks good. And then here we're going to load up that file. So we'll do let byte file. It's going to be standard fs read from args1. So this is going to be expect failed to read repro file. And this is going to be the load the bytes from the file. Pretty simple. And now we're going to want to convert this to a structure of commands, which is going to be a vec of u32s. Command vector. Convert stream of bytes into, and here we're just going to assert byte file.len mod standard mem size of u32 is equal to 0. Repro file was not 4 byte aligned. We can say u32 aligned. Then here we'll do convert the stream of bytes into a vector of u32s for slice in byte file.chunks 4. We'll do commands.push slice.try into .unwrap, and then this will be u32 from bytes. Print, we'll just do a panic. Command stream is this, and we'll commands here. We'll see what happens. We need try into. This is in use standard convert try into. Oops, I really don't want to use PowerShell. Okay, and we have some issues at a couple places. What do we have? Args. This will be a .collect. .len. Here. Okay. Args1. Primary window, unreachable, yep. And then we'll make this mutable. Okay, and here we'll do OXOD. That looks correct. Okay. And we'll just, well, we've got calculator open here, so we'll do a BD star. And we actually want to get the stuff where we create that calculator instance and delete the registry keys. So we're going to look at that in calc state, because the state of calculator when we fuzz it is a reset clean state with no registry keys. So we want to make sure that we delete it and run it ourselves. So at this point, we're ready. We're going to do delete all the state, and then we're going to wait until we can attach. Okay. Win32 calc, we'll spawn that, then we'll wait until we can attach, then we'll actually attach, and then we'll try and send the commands to it, and hopefully this is good. Use standard process command. See what happens. Okay, all commands were sent. So it's hard to say if this is a failure of repro, or if it's a different state of this bug, or it could potentially be due to this calculator having different IDs. So we just need to be careful. We don't want to get upset yet, because we likely can find a way to get this to repro. So gflags I, actually windebug-i, make up postmortem. I mean, that looks bad. I mean, that definitely looks bad. And this is with page heap on? Oh, look at that. Does it repro every time? Hell yeah. Look at that. Okay. So we have a clean way of reproducing this bug. Let's see if this is always the same. Let's see what it's about to do. It's gonna load. It's just gonna load this into EAX. Heap PARCX. We can see this heap allocation that we're in. Hey, Madu, how's it going? Are you just exiting? What do you mean by that? Because we have it reproing. I don't know. Maybe your stream is slightly delayed. Oh, look at that. That's that looks like ASCII. Oh, it looks kind of like ASCII. I don't think it exactly is. We're dereffing RCX. We've got page heap on, right? It was quite delayed. Yep, no problem. So, I mean, we definitely have a reproducible crash. It's not crashing in exactly the same way, so what we could do is we could turn off page heap. Gflags I win32 calc.exe minus HPA. We can see how this crashes. This crashes in a null deref at B0. So this is probably going to crash based on the state of that allocation. So what I think we have here is likely a use after free. If we put HPA back on, we'll see that the crash we're getting, it's trying to access an address, and this address does look relatively valid. And when we're looking at a relatively valid address, we can say heap PARCX. And what we see is that this block is, so this was found, DAA ODC. So it looks like we have an out of bounds access of something that's valid. If we look back like 100 bytes, we'll see that it is valid and then it becomes invalid. So here's the location that we see that the allocation occurs in. So this is saying that layout standard mode, this is what is causing the allocation to occur. We see that the size of the allocation is 238 hex bytes. And then we see that the what we're trying to access, it's hard to say what this is. It looks kind of like an out-of-bounds access. I don't know why RCX would be getting out of bounds at this point. So let's check in on the fuzzer quick. But this looks really good. I mean, we have a reproducible crash. We can take a look at the other crash as well. So that was 2AC, and we can take a look at the NTDLL crash. This one also is reproducible. It looks like in the exact same place. So I'm guessing that there's a pretty big issue on this access, potentially an out-of-bounds access here. Doesn't look like a use after free. Doesn't look like anything of those sorts. So we can see where this allocation came from. This one also came from this layout standard mode. But it's really cool that we have a reproducible bug here. So this shows kind of the quality of bugs that you get out of these like more deterministic setups where you're working with an input stream that's perfectly replayable. Isn't that cool? Isn't that really cool? Like, we sent this off into box, sent it off to a server. It ran on 64 cores. It then dumped out a file that contained some bytes that if we load up the bytes, treat those bytes as U32s, and then send those to the calculator application, we get a reproducible bug. I love it. It feels so good. Like, this feeling is fantastic. I just love this. So we can see what Analyze V says. Analyze V is usually worse than what a human can do. This is just going to say an access violation on a read. Yeah, this is not telling us anything interesting. What is interesting is the allocation size here. So I think what we want to do is we want to try and figure out where in the stream the crash is occurring. We want to try and minimize this stream down. So what we could do is try to delete random portions of this and see if we're able to get the bug to still reproduce. If we can get this down to as few commands as possible, we could then potentially find where we could put some grooms in. So we also want to figure out what possible ways that we could groom. So in this case, if we have an out-of-bounds access, that's a little bit difficult. We're going to want to get something adjacent to it in the heap, which is not necessarily as easy as getting like a use after free, which is usually as simple as just getting something in the same bucket. So what I also want to do here is we might actually want to set up a development environment in Windows 7 such that we can do our development in a VM in Windows 7. Mainly because if we, I don't know if I want to do a Windows 10 heap exploit bug. The heap has gotten significantly more difficult to land in Windows 10. There's some randomness that makes it a little bit harder to do research, which is fantastic. Like, those mitigations are great. But for a bug that's meant to be kind of silly and kind of fun, I don't know if it's really worth putting all that effort in. It's basically, we could either write an exploit from Windows 7 that would maybe take a couple days to write, or a Windows 10 exploit that might even be impossible, if not take a month or two to write an exploit for. So all the techniques we're going to use are going to be pretty straightforward here, but I'm going to grab my tool called Bride and Groom, which is meant for kind of doing analysis of... it's meant for doing an analysis of an application such that we can see what allocations and frees it performs, and we can use that to try to figure out which allocations are active and which ones are stale at different times in the application. So if I go into Bride and Groom, and this has a little README, so if we look into the README, and this is open source as well. I can get you the link. GitHub, Bride and Groom. So the link to this is just right here. So this is just meant to be a simple tool that allows you to do some analysis of heap allocations. This is done via the xperf utility on Windows. This can also be used against kernel targets. Doing scalable dynamic analysis, we lean towards Windows 7 for perfect memory nuance reasons as well. Yep, absolutely. It's an easier environment to work in, I would say. I would say Windows 10 is probably an easier interface, and it's probably better for 99% of computer users, but the 1% of power users who are doing development and things like this, the modern UI and overheads and complexities of Windows have really hurt the ability to use Windows as a power user. All my machines, so you're on my gaming machine right now only because this has my best graphics card for streaming, but all of my research machines I use Linux. Even at Microsoft in my office I have Linux installed on my workstation. I really don't support the direction that Windows is going there. Then again, I'm selfish and I don't care about the average user being able to browse the internet or handle their email without guidance from an IT person. I want the computer to give me as much raw access as possible. So basically what we're going to do is we can look at the README formatted prettily here. If you're not using PID new process, which allows us to spawn a new process with xperf, we have to set this flag in the respectable executable, and that will turn on this tracing for that application. We can turn on the NT-kernel logger, which we'll need to do for as admin, and then we're going to start a capture, and this will either start a capture with PID 0, which will be, it'll attach to whatever tracing, whatever things you set tracing flags for. But in the case of starting an application, you can actually just give the application you want to run, and then this is how you stop the capture. And this has some pretty printing. It's a really straightforward tool. The tool itself here, so this is all done with Windows xperf, nothing we have to do. The tool here is actually a Rust parser that allows us to parse that into a meaningful setup such that we can do some analysis, graph analysis, dependency analysis on the allocations to figure out roughly how those allocations work. And I haven't used this tool in a year. I can't remember if I wrote this code well or not. There's a chance that we might have to make some modifications to it as we do this work. So I'm going to start an admin prompt. You're going to black screen for a second, and we're going to turn on xperf base. And then what I'm going to do is I should be able to do this as a normal user. This will start a notepad session. If I exit that, I should be able to do this. This will cause, yep. Okay. Stop heap session. I might need to do kind of everything as admin here. I'm not quite sure. Xperf on. We're going to run notepad. We're going to close notepad. And then we're going to stop the trace. Okay, yep. Trace ETL has PII. And now what we can do is we can see all the things in the trace. In this case, we said I want to track heap alex, realex, creates, destroys, and frees. And now this will parse that trace, and here we can see this is going to have image load information on it. So this is going to have things we don't care about in here, and this is exactly why I have the parser. So this will symbolize it. Basically, this will be delayed while it downloads the symbols for these things for the first time. And what I'm going to do is I'm going to output this to a file. Is it trying to write to system32? I don't think so. Oh, yeah, it might be, actually. Let me see if I can do this without admin. No. Well, maybe I can turn on the kernel logger. And then if I do this... Yeah, I'm going to need to be admin for it. So we'll just turn this off. Heyo, how's it going, George Tesiros? We also had a couple people follow. We had Madhu follow, and we had Sip12 follow. Welcome to the stream. Hope you're having fun. We are in the middle of trying to figure out how the heap looks for calculator, such that we can find a groom, and we're going to try to get arbitrary access of a deref. We don't really care about code execution yet. We're looking more to learn how we can get control of the heap in Win32 calc. So, we've got our tool here. I'm going to go into Bride and Groom directly on this machine, or in this terminal as admin. And then, if I'm not mistaken, I think I made some files in registry setup that allow us to start and stop. Let's see what we got. So we got start log. Yep, and we're just gonna grab these and make copies. We'll put this in calc fuzz, and then we're gonna make a git ignore, just so we don't end up committing this up. Not that it really matters, but I just want to make sure that I can do a git commit am and push up these changes if we end up changing Bride and Groom, as that's an open source tool. Okay. Take control of Heap. Yeah, effectively, we're going to want to get... Yes, we're going to see all of its allocations. So that's what we're going to work on right now. We're about to make those traces. And then once we have processed those traces, we're going to try and determine which things that are user-controlled that would allow us to allocate arbitrary things on the heap. And then we're going to try and get a bunch of A's in the heap and see if we can get a deref of A's. So that's the direction we're headed. We shall see how it goes. So we've got parse log, trace.text with symbols, looks good. We've got start. This is going to be, we want to use this command. I'm actually really glad that I wrote a good README file for this. So one thing that you'll find pretty frequently is that writing README files and polishing the things you do pays dividends in the long run. Win32 calc.exe. We'll have that stack walk on everything. That looks good. And then we're just going to modify this. Experf stop heap session D. That looks good as well. So we should be able to do calc fuzz start log. This will start a calculator instance. We can now do stuff in here. We can now exit. And now we'll want to do calc fuzz stop log. That's going to process that log. And then we'll do calc fuzz parse log. And in fact, we're going to put parse log right in here in the batch file. Parse log. And I don't know if that's going to be in the right environment there. And we have symbols on, so this is going to take a little bit longer for the first run as it discovers and downloads the symbols for those DLLs used. Wonder if the source differs for calc.exe between 32 and 64-bit? Nope, not really. But for Windows 10, it has been completely rewritten. It's actually terrible in Windows 10. I hate it. Which sucks because it's open source, but it's like all the UWP kind of fancy interface. I mean, here, this is a good example. I'm going to hit enter, and then we're going to count how long it takes for a calculator to open. 1, 2, 3. Took 3 seconds. 3 seconds to run a fucking calculator. Are you kidding me? Whereas Win32 calc, it's open. We're just moving in this direction as a society, as programmers, as developers, as consumers of tools. We're pushing this like fancy interface stuff. And like, who wants the scalable buttons? Like when I full screen this layout looks terrible. Like, this is unusable. Why are the buttons wider? Why like... And then this memory thing. The memory thing, you can't turn the memory view on and off. It's just there whether or not the window is wide. It's just so silly. The emulator for the HP48 opens and loads the ROM in under a second. Yeah. Oh, yeah. So I actually physically have an HP50G right next to me at all times on my computer. So when I'm just doing math, I'm always using that calculator, and I have RPN, which makes it a lot easier. So, yep. I even have all the button. You can hear the button noises, but yeah, the HP50G is pretty much the only way to go for me. I love it, and this calculator I bought new for I think $120. And now I can sell it used, I think, for $300. So, yeah, that goes to show the quality of that calculator. I love it. There's something to be said about a good calculator. We've got Molark11 has joined the party. Thank you for following. And George Cyrus also. Thank you for following. I think you mentioned how to pronounce. You said it's like Cheros? Cheros? Is that how I just say it? Like George Cheros? Cheros? The TSI, I'm guessing, is making a che sound, a cheer. Yeah. That's really cool. So I don't know why this is taking so long to process. We can see if it's doing network activity. Looks like it might be. So there's a chance. It's hard to say if it's downloading the symbols or not. I'm just gonna let this run for a while. We can poke around at something else quick. Let's check in on the crashes. So we've got fuzz cases, everything looks good. This TSNC is time since newest coverage. So this kind of counts up as long as we don't have new coverage growth. So this is saying it's been 16, 17 seconds since we've seen a coverage increase. So yeah. Because the Microsoft symbol server is the slowest thing in the world. It's actually not the symbol server. It is the SymCheck is just really slow. So, whenever you doubt, I have a tool for that. I forget what I called this tool. I don't think anyone uses it other than me, but it is PDB Lister. And basically, this is a high-performance version of SymCheck. And this will guaranteed saturate at least a gigabit per second, for sure. It consistently does. Whenever I'm setting up reverse engineering, so I do almost all of my research offline. I have an offline network. That's where I do all of my research. So this allows me, I will go and grab, this allows you to do like PDB Lister, manifest, and then you give it a path. It'll recursively find all PEs. I do the PE parsing myself because SymCheck is slow at that. And then when you're done, you can just say PDB, you can move that manifest file somewhere else. And then with internet, you can say PDB Lister download, and it will download all the PDBs as fast as possible. And I've used this numerous times, and it always saturates at gigabit. So basically, this does a parallel download, and the server itself is, I don't know if it throttles based on individual PDBs. I don't know if there's just a huge amount of delay in the downloading between PDBs, but whatever it is, that tool actually internally uses SymCheck. So what we do is we get a list of all the files, we then split those up, and then we invoke like 60 instances of SymCheck. That way we can make sure that we're always compatible with the formats that SymCheck use. I didn't want to rewrite all that parsing stuff because there was a chance that we could potentially kind of break all of that. It appears to me you're at least somewhat knowledgeable about behind-the-scenes workings of the extra information that a compiler outputs. Yeah, I'm pretty comfortable with that. I've done a lot of JIT development. I've done a lot of like code generation sort of things, so I'm familiar with that sort of realm. I've written parsers for almost every single format under the sun for, yes, JIT, not GIT, yep. So just in time, like emitting code to execute. So like my emulators that I write will actually lift, convert in an IL, perform optimization passes, and then emit x86 equivalents of what that is or whatever I'm doing. So that is my main research project. It falls under that that sort of work. I mainly write emulators full time in this day and age. Although now I've been working on this TKO fuzz tool. But I've done a lot of emulator development. So that is completed now. I'm going to just see how fast it is this time. I'm going to see if it's slow again. It looks like it might be slow again. Frustrating. It's not slow without symbols. Hello, Uzi. What is BNF? In what context? Okay, that was faster. So it did seem like there was some caching or something that happened. So now I should have a log in trace.txt, and I should be able to do cargo. So this is designed as a library. So it's designed to just do the parsing for you. Okay. So let's see. Okay, so what we're gonna do is we're going to go into Twitch Fuzz Calc. We're gonna make a new thing. We're gonna call this Heap Checker. And then this is going to use Bride and Groom as a library. And that means we're gonna take the calc fuzz stuff here. We can delete that line from the file. We can delete these traces. And now we can also put these in the root directory to make it easier. And then we're gonna make a new project here in Heap Checker. We're gonna do cargo and bin. All right. So now we have an application here, and I'm just going to grab cargo.toml. We're going to add a dependency. We're going to say we need bride and groom. This can be found at path d:/dev bride and groom. Let's make sure that pulls it in. Looks like it does. That variable doesn't need to be mutable. So let's go into bride and groom. Let's fix that. I don't like any warnings in my build process because it can hide meaningful warnings that might tell you that you did something really wrong. So that looks good. We now have this, and let's see how we use bride and groom. So it looks like, I'm guessing it's just going to take a file name. Damn right. Nothing new here. In the source file, which we might have open already. We can close that. So now we can do Bride and Groom just on trace.txt, I think. And we'll make this return IL result. Bride and Groom. Heap transactions is equal to this. Return OK. I'll bring in standard IO, and then here we'll do a debug print. Yeah. Of heap transactions. So what I should be able to do here is I should be able to run start log and then stop log. I think we changed to do parse as well. So we're gonna make, yep. So we'll do start log, boop. We got a calculator. We'll just do a couple interactions. Then we're gonna close calculator, and then we'll do stop log. That will stop it, collect the trace, and then it's going to give us, it'll parse this into a trace.txt file, which we then should be able to run we should be able to cargo run, and it will parse that for us. For the parser that is BNF grammar as its input and can parse any language that you give it. That's really cool. I've actually never really worked with the language side of compilers. I've worked with the code generation and the optimization and like that sort of stuff, but I've never actually really written like a lexer or anything like that. So that's, I don't know, I guess one pattern you'll find in a lot of my tools is they're usually not very human friendly. So, okay. So now what I can do is I can do cargo run. We'll do a release build, and this should apparently parse this and give us a list of all the allocations that occurred. And it looks like it did. So if we look through, these should be all of the allocations. So this is saying a new heap was created. This is where that heap was created in the calculator application. We can see various different things. So this is the call stack for every allocation that occurs, the address of the heap that the free occurred on, the address that was being freed, all the traces. So we can see calc in here, all of these things, which is really nice. So then, surprisingly few heap allocations going on there. Huh. So what we want to do is we want to see if we can cause... Here's a 620 heap allocation. What's the heap allocation that we're going out of bounds on? Where's our repro window? That I'm going to move off screen. So here, run this repro through. We got a crash. And we have a 238 hex allocation. God, that's so annoying. Oops, 238 hex is 568. So how much you want to bet that... Actually, this is layout standard mode. So what we can do is we can write a... we could maybe do a... I'm trying to think how I want to go about this. Huh. Interesting. So we know that we get a 238 heap allocation. So what I want to do is I want to see if pasting a text buffer into calculator in any location allocates something of the size that we're looking for. So the heap looks actually really clean for calc. Like, this has... Like, if we look at it, it looks like there are very few allocations. So what I'm going to do is I'm going to slightly make this pretty printing easier to read. I'll make it slightly more condensed. For transaction in heap transactions, we'll print out the transaction that occurred. And in this case, it, whoops. And then we don't want to put a pound sign. Okay, that's kind of gross. Let me see. tcon/dev Bride and Groom source. And I just want to see what it is. It's a vector of tuples. So this will be the action and the stack. So now we'll only look at just the action. And this should be a much more readable output. So here are all of the actions that happened. It created a couple different heaps. We're going to make this hexadecimal as well. So here we see it created a couple heaps. It created 4 different heaps. It performed an allocation. It then freed that exact same allocation, created another heap, performed an allocation, freed it, allocated it, freed it, created a heap, destroy, destroy. So what this is telling me is that calc almost never has an active allocation on the heap, which means that the heap is very clean, which means that landing a bug might actually be really easy. I'll drink to that one. You're basically tracing the executable. Yep. Yeah, we're kind of logging. We're using the Windows APIs to log all the heap transactions, and then we're parsing those heap transactions into a nice Rust object format that we can then do like lifetime analysis on to determine the length that things live for. That's kind of the goal of this library. It's just meant to be a really easy way to get Rust bindings into heap transaction logs. And it works great. I mean, we didn't have to change anything in it, and it just worked out of the box. So I'm actually really happy with this. We can put an underscore here because we don't care about the stack currently. Okay, so let's check in on our crashes and our fuzzer. Let's see what it's looking like. Looks like all the fuzz jobs are still up and running, which is good. We can always restart it if things start dying. I do know of like one panic in there that happens over time. CPU usage looks beautiful. Everything's being used almost 100%. We have almost no kernel activity. The way that I kind of designed the emulator and everything, there shouldn't be actually any syscalls. So regardless of the OS, the performance should be the same. This also means that things like the mitigations that we get from the mitigations that are in place due to Spectre and Meltdown aren't nearly as impactful, so we're not getting punished by that. So let's see what the status is like. Everything looks good. been running for almost an hour. This is the second run, 1.73 fuzz cases per second. It's been over a minute since we've gotten a single increase in coverage. Actually, we just got one. So we just got a single increase in coverage. What's really cool is that I keep the coverage files in sequence. So what I can actually do is I can go in there and we can look at what coverage just happened. After 1 minute of not getting any coverage, we can see what we ended up getting. So I want TKO fuzz. Oops. TKO fuzz Franzia. And we're going to take a look at the calc step coverage. If we look at the end, we just got like a new thing in NTOS kernel. But what's interesting is that we are getting some new coverage in calculator even up until this point. So let's see like what a really rare block of coverage is. This is after like 2 hours of fuzzing, we found this block in calc.exe. So we can take a look in the iters. So this block, is that right? That doesn't look right. So, I guess maybe that is right. Interesting. Not quite sure. Alright, so are you just doing random calculations in calc.exe? Effectively, we're doing random calculations and we're doing a lot of different interactions with the calculator process. So we're clicking a bunch of random buttons. I doubt there'll be any bugs in the calculations. If there were a bug, it would be in some sequence where you write a number, clear it, and write another and continue. There's actually one bug in the calculation sequence that results in an infinite recursion. I don't know if we have that crash in the database. Oh, here we just got... We got another general protection fault. We got this 3 minutes ago, we got this. And then we got another write user in NTDLL. This is also interesting. This one is also really interesting. So the last 3 bugs we've gotten are all exceptionally interesting. Let's take a look at them. Yeah, don't doubt the power of a shitty fuzzer. More specifically, don't doubt the power of poorly written C code. I'm not saying that the calculator application was poorly written. I don't want to insult the developer, but no C developer can write without bugs. It's just too difficult. The language does not fundamentally allow you to write things without bugs. It's just, and that's fine. There's nothing wrong with that. We shouldn't be rude to our debugger, to our developers when they make mistakes. They should be allowed mistakes. So here we're going to take a look at this crash. This is going to be a write in NTDLL to user address that's invalid. This is likely, I bet all of the ones that are massive corruption, all the bugs that we're looking at and we're saying, oh my god, that looks good, I can guarantee you they're probably all the same bug. At the end of the day, it's probably the same primitive at the end. So this one looks like a stack exhaustion, and here it is. Here's the bug. Here's exactly what we were talking about. So there is an expression that you can input into the calculator that will cause it to infinitely recurse and obviously crash once we hit a stack exhaustion here. So we're crashing on a push R14. We're trying to push to the stack, but the stack has been exhausted. So, yeah. So this looks fantastic. So we got that crash coming through. That's nice. I'm glad that we exercised that. That's not an exploitable or interesting bug. Now we can take a look at this one. I need to figure out why it keeps rebuilding every time. There must be some file in there that's not blacklisted in the... What's going on here? Let me restart this for some reason. Okay. I'm gonna hit go. I'm using Python as well. Have I used Python in this stream? So here, this is going to be another one of the stack exhaustion bugs. Yep. And then we're going to take a look at this one. This one will not be stack exhaustion. This one will definitely be really broken. So we'll do .crash. So this one, and we'll take a little gander. This one I think we know of. I think it's just going to be a different crashing variation of the one that we know. Actually, I don't know if we've seen a D at 2A5A5. I think that we've seen a high there. I'm not quite sure, actually. That's loading ASCII. So if we look where we are, we're in toggle history, switch history again. Here we're dereffing an ASCII string. We can try and look at where the RDX value comes from. It came from racks plus 18. If we look at that, we have ND space I in there. We've got a number in here nearby, which is kind of indicative that maybe there's something we could control here, which is really cool. So cool. We didn't really learn anything new there, but we're now up to 27 quote unquote unique crashes in calc. I guess 3 of these are not in calc, so 24 unique crashes in calculator, which is pretty cool. Need any more cores? I'm pretty good. I've got this up and running on my 64 core server right now. Let me actually see if I have FileLand on right now. I could bring FileLand up. So this one has 256. So if we really need to get into it, we could maybe spin it up on this. Now these cores are really weak. This server would actually be like pretty comparable to the other. I mean, we can see what happens. I think this is just gonna bottleneck, and it's probably not gonna make any progress. But sure, fuck it. Do you have TKO fuzz? Nope. Okay. I think for TKO fuzz, all I need to grab is the, I'm actually just gonna skip it over from the other machine. I'm gonna grab from archive, I'm gonna grab from TKO fuzz brawler. Target debug brawler. Game u.be fatal. Okay. What server? 1, 2, 3, 4. I mean, we'll see what happens. I've never tried to scale it out this wide. So it looks, we've now got 320 workers. It's going to take a long time for those to sync and come online. But yeah, I don't think these are really going to have any performance to them. But hey, you know what? We got cores. Let's throw them in there. So the Xeon Phi, I actually have fuzzers that I designed specifically for. I have something that I developed called vectorized emulation that uses AVX512 to fuzz applications. It's extremely high performance fuzzing, usually looking at the order of like 1 to 10 million fuzz cases per second on a single Xeon Phi. That's basically my like state-of-the-art research that I work on. I write some blogs on that. I've given a talk on it now, and I actually won a pony for it. I won a pony for most innovative research, I think, this year at Black Hat, which is that was quite a feeling. I was actually on a plane when I landed. I checked my Twitter, and people were saying that I won a pony, and I was pretty surprised by that. That was really cool. So I'll drink to that. So right now we're going to be having some network, so we're just sending a shit ton of stuff. We're syncing down all the inputs and crash information to this server. Hopefully this isn't impacting the stream. Let me check stream stats. I think we're fine. Have you played Pwn to Own or competed there? No, I have not. So that's not really the sort of thing that I like doing. Yeah, this is my LAN. So this is actually my online network. This is my gaming computer, so I don't really care about it. My offline LAN actually is 56 gigabit InfiniBand. So I get spoiled by that. But here's the thing. At the end of the day, an InfiniBand network costs $3 grand to set up, something like that, to get like a couple computers configured with InfiniBand. Okay, we've got fuzzers up and running. I am going to be curious to see what the performance we get out of this will be. So like here we're seeing a couple prints a second, maybe like 3. I guess it's like 2 was our performance. Here I expect that this whole 256 core server will underperform this. This might be close. I'm not quite sure. Oops. Well, it's working. So, got those up and running. It can't even fit on the screen with this font. Love it. Absolutely love it. We'll go to like an 8-point font. There we go. Now it fits on the screen. What is my power bill? I don't care. I'm just gonna pay it. I don't know. When I'm doing a long time of fuzzing, I'll probably get to like the $250 or whatever. This Xeon Phi is actually a really low cost. I also have a much higher power bill because I do the thing where I pay for like the green power, even though it's just a grid and whatever, but I do that, which makes my power bill like artificially 30% higher than what it should be. But power is actually pretty cheap where I am. I think I paid like 12.5 cents for the first few thousand kilowatt hours, I think, or like 1,000 kilowatt hours. I'm not sure. But yeah, it gets expensive in the summer when I have to cool the servers, but right now I don't have to cool them at all. They actually are cooled off the outside air right now because it's cold enough outside. So these servers are running just fine and dandy. So honestly, this is kind of performing similarly to this. And also, this 256 core server runs, I think, at about 200 watts. So I could go check that out. This is Philand. I can go see what we're running for power on this. So, server's on. What is unhealthy here? I don't know why that's blinking. Oh, I actually have a PSU that's failing. So ever since I bought this server, this PSU kind of fails. I have to unplug it and replug it every once in a while. I probably should replace it, but I'm kind of lazy. But yeah, right now it's running 26 inlet, which is pretty cool for not having to run AC right now. And this whole server right now is running this whole server right now is running about 297 watts, 300 watts, which is actually extremely power efficient. So, but yeah, it's pretty cheap to run this server. This server is basically free. Yeah, 300 watts is peanuts. It is, absolutely is. So there. Now we have 320 cores. 320 cores fuzzing calc.exe. Kind of ridiculous. No new crashes coming in, but I mean 24 unique crashes in a calculator is Pretty good. But yeah, the Xeon 5s are really power efficient. I love them. They actually discontinued them, so I'm planning to buy a couple more as they come up. But yeah, we can... there we go. We have 320 fuzz workers running right now. And they're all playing together. What is going on? So you have stumbled into a stream where we do fuzzing, security research, and just really weird like programming. So effectively, the goal of this current segment of the streams, like the theme of these streams, is effectively we're going through and we're trying to find bugs in the calculator application. And when I say calculator, I mean the old school calculator, which is this one. If you've seen it before, it's the standard calculator that ships with Windows. What's interesting about the calculator is that as a security researcher, as a hacker, as someone trying to find a bug, when you're trying to find an exploit for a system to land a bug and prove that you've gotten execution of a machine, like you find a bug in Chrome and you want to demonstrate that you got full control of someone's system through a bug in Chrome. Typically what you do is you pop calculator, pop calc, and it's usually an indicator that if you are able to launch an application like calculator, it demonstrates that you have a pretty good foothold of the whole system. You're able to get this full control. And basically, our goal is to do like a meta joke where we're going to try and find a bug in calculator itself such that we can get code execution, something that we can exploit, a bug that's so severe that we can exploit calculator to get arbitrary code running in the calculator process that will then allow us to pop another calculator instance. So it's mainly just like a meta inside joke for the security community, but reason aside of doing this task, we're going to learn a lot. So we've been writing fuzzers, we've been learning about how GUI programming in Windows works, we've been learning about how you can interact and enumerate an application, and kind of all these different things. How many calcs can you pop via calc? I guess unlimited if we can nest them. So, okay, let me catch up on some of the people. SIP12 or SJP12, actually I think I already got to that. Mulark11, thank you very much. George, thank you very much. I got to you as well. Navy Sneal donated. That is the first donation I have ever gotten streaming. So thank you so much, Navy Sneal. I'm glad that you're having fun. I'm having a blast. I've had good food. I've got a little bit of whiskey here, and we're having fun. So thank you so much for that. That is huge. Lord Dankington has followed. Thank you so much for the follow. And CMSH or CMSCH has also followed. Welcome to the stream. Thank you so much. So yeah. Kay Ellison, I'm pretty sure I know who you are. Thank you for following. If that's Kirk, how's it going? Hope things are going well. Hope your cars are treating you well. Glad you're here. All right, so basically, we spun up those extra 256 threads to fuzz calculator. We're now... We might have... We probably have the world record for most calculator interactions at this point. Because, yeah, the fuzzing speed is climbing. Sadly, this is an average over the entire time. I need to make this a moving average. But yeah, we're now probably running, if I approximate from the visual output of this, maybe 2 per second. It's hard to say. Maybe 1.5 per second. The other one's giving us 2, so we're probably at about 4 fuzz cases per second. With 320 cores. But keep in mind, we have a 60-second timeout on these fuzz cases, so they're very long-running fuzz cases. But yeah, that shows the scalability of TKO fuzz and how you can just add more workers, and everything just kind of works. Really exciting. So we haven't gotten a new crash in the past 20 minutes. At this point, I don't expect to crash for like an hour. But we can get back to what we were doing, which is kind of looking at the heap state of calculator. So we have an application, we have an open source library called Bride and Groom that allows us to kind of parse and look through all of the heap transactions that are going on in an application. We're using this to figure out what is possible on Word, or not on Word, on calc.exe, and we're going to try and figure out what the state of the heap is in. So if you're tuning in just now, one of the bugs that we got out of the fuzzer, so we grabbed one of these crashing inputs, we wrote a tool that would allow us to replay it. So if we take a look at this tool, we actually have it open already. So this tool is going to take an argument, which is the file name to repro. We spawn a thread to exit over time. We don't even need that for this. We load some bytes from the file. We convert those bytes to a slice of U32s. So we load up the file and treat it as an array of U32s, so unsigned integers, which are 32 bits. We then delete the registry keys associated with calculator to reset the state. We spawn a new calculator instance, we attach to the calculator, and then we send all of the commands in the repro file. And what happens when we send it a repro for one of these crashes? Boom. We get calc to crash. And in this case, the crash that we're seeing is on a read of this RCX plus 2C8. I've got page heap currently enabled, and we can see that RCX is, RCX is valid, but if we add the 202C8 to it, we see it's invalid. It's now out of bounds of this allocation. If we do a heap PA of RCX, this will give us where this allocation occurred. In fact, we could add the 238 to see it'll give the same result. So this is saying this is the location that an allocation occurred. It was a 238 hex byte allocation, and we are getting a crash when we're accessing 238 bytes into it, which is actually, is that a coincidence? Oh, 2C8, sorry. So we're accessing 2C8 bytes out of bounds, but it's fine. This is saying this is the nearest one. It was trying to allocate something, and this is actually an object, so there's a chance here that we could get some crazy stuff going on. Okay. Would you say it's like AI? In this case, I would say that fuzzing with feedback is technically classified as a type of artificial intelligence because it is doing feedback. It's learning from what it's done, and it's building on top of things, and it's tuning basically weights, the inputs, to try and find better and better inputs to explore this space. So fuzzing is absolutely in the realm of AI when you have that feedback. I actually have a project that I wrote that demonstrated that. I wrote a fuzzer that was able to basically generate the same sort of outputs that a neural network could using all the fuzzing primitives. Let me pull up that project. That was on github.com. It was just kind of like a fun little project. Let's see. But yeah, it's hard to say if people would consider fuzzers to be AI. I would absolutely argue they are AI. I wrote this tool that effectively goes through, and what this does is without feedback, it just generates random inputs, and then with feedback, it does not generate inputs, and we're able to get like, this is basically trying to find XOR, which is the meme thing that you do when you're writing a neural net. You try and have a neural net that learns how to implement the XOR bitwise operation. In this case, this is the number of mutations until we've correctly implemented XOR. And if we're using no feedback, it takes forever. But the second we turn on feedback, we're able to get almost immediately a many order of magnitude improvement to the time it takes to get the same result. And I would say that in itself is definitely an ML sort of thing. Maybe not AI, but at least in like the ML realm of classifications. So anyways, we've got this repro, we've got this interesting crash. And what we're trying to do is we're going to try to figure out if there's anything that we can do to this application to cause the heap to be in a state that would maybe cause this to deref 4.1 instead of this out-of-bounds access on an array. So let's see. Let's see what some of the other crashes repro like. These rights users, those were the stack exhaustion. Let's grab another one of these examples. And this one is the 2A5. So we're going to see how this one repros. This repros in the same way, it looks. Yep. So out-of-bounds access on this array. And this is with page heap. If we don't have page heap on, that succeeds, and it kind of continues on to end up doing a null deref. So we could try to figure out what necessarily is causing the out-of-bounds access. Maybe it's controllable how out-of-bounds it is. I don't think it is. You know what? It might be a use after free. Skip Witch, off for the night. Thanks again for the stream. We'll check out some recording sometime. Thank you so much for tuning in. Hope you had fun. Okay. So there is a non-zero chance, and these are kind of the thoughts running through my head. So in this case, it's really strange that there's a hard-coded offset on a deref of an object which is correctly where it belongs. So if I look at heap PA RCX, heap PA of RCX, I see that the base of this allocation is at this DC0. And if I look at RCX itself, we see this is also DC0. So why would there ever be a situation where we would be accessing 2C8 hex bytes all the time on an allocation that is 238 bytes in length? And the only thing that really makes sense in this case to me is that this is probably a use after free. I suspect that what is happening here is we are freeing an object. We are then filling in with a smaller object. So we're freeing a 2C8 object. We're freeing that. We're then allocating a new object of 238 bytes in its place. And then we're accessing out of bounds. Because it would make really no sense. Yeah, it could be type confusion as well. It does look very type confusion-y. It's either type confusion, a use after free, and out-of-bounds access doesn't really make any sense for a non-dynamically computed offset onto a pointer that's already at the base address of its allocation. So type confusion makes the most sense at this point. So what I'm going to do is I'm going to validate whether or not it is actually type confusion. We're going to go through, we're going to enable a Bride and Groom, and we're going to see what all the heap actions are. In fact, we just got a new crash. Let's check out what this crash looks like. This is a right user. It's nearby, kind of to these other ones, and I can actually pretty quickly... I'm going to hazard that this is probably another stack exhaustion, which is not a big deal, but hey, a bug is a bug. We learn from bugs. So we're going to take a look at this. This could also be some crazy bug. This is either a crazy bug that's like, holy shit, this is the one, or it's a stack exhaustion. And my bet is on stack exhaustion. So we're going to pull up our debugger. We're going to repro this in the debugger to see what it looks like. Cool. Uzi, off to sleep. Thank you for showing up. Hope you had fun. See you around. Okay. Oh, I didn't hit G. Sorry about that. Might be time for me to refill my scotch here soon. I actually just finally ran out of scotch on my on the scotch that I prefer to drink. But we've got backups. So we're gonna push our 12. This is definitely gonna be another stack, infinite recursion. So not a big deal, not losing sleep over it. Hey, a bug is a bug. Every bug we get, we're learning more about the application. So now what we're gonna do is we're gonna slightly change this heap checker, and instead of actually starting the calculator application, we're gonna make this use the PIDS 0 mode. And we're going to have to look at the Bride and Groom usage information to tell us what to do in this. If we do the PID 0, we have to set this for our application. So I'm going to make a gvim reg.reg, and we're going to just manually edit this, and this is now going to say win32 calc.exe, and we'll just run that to apply that registry key. Yes. Apparently that string is important. Okay, reg.reg. Yes. Sweet. So we've now updated that. Now we can do start log. We'll be able to run our repro. I'm going to make a dump of this. /calc.dump. We're going to close that. That's now exited. And now we can do stop log. And this should stop that. And we should now be able to see all of the heap transactions that occurred in that calculator instance where we threw the exploit. And this will give us a more definitive idea of what actually happened on the heap and why this access is occurring. Okay, we're just waiting for this to parse. Once this is done parsing, we're going to be able to run our application, which will go through and parse that log for us in a nice, pretty Rust format. So we'll actually get to see what the heap transactions, look like when we run this. Man, we're at 40 viewers. That is incredible. I gotta say, that's so cool. You know, I never would have expected to like have a stream